Hello, dear colleagues. So, welcome to Lithuania, welcome to Kaunas, welcome to Kaunas University of Technology. I'm very glad to see you here in this anniversary conference, and it is nice to see the colleagues from Lithuania. It is nice to see the foreign guests, foreign colleagues who participate here in this conference on site. As well, it is very nice to meet online colleagues, and I'm very happy that all of us are here. And we went a long path, 30 years long path till nowadays. And we will start this conference from brief 15 minutes video. So, thank you very much. Thank you very much for very beautiful movie. And now, according our schedule, I would like to introduce for welcome speech our Dean of Faculty of Informatics, Professor Jonas Čeponis.
So hello everyone. It's nice to see you here in Lithuania, in Kaunas. Today is not very warm, but quite sunny. We have closed windows, but without if this window will open, so it's too bright will be here. So nice that you are here, and nice that we have a lot of presentation about computer science, about ICT, about cybersecurity, because in these days, without these fields, we even can't imagine our future life or even these days' life. So my wish that all of you here who participates on site and who will watch this our presentations, not our but yours presentation, will acquire new knowledge, will, how to say, make new connection between ICT specialists from various countries, from various universities. And I think that these 2 days will, how to say, add new knowledge for you, and I wish you very fruitful discussions, and I hope that after this conference, organizers will be very happy, as was said in that short movie about history of this conference. And thanks organizers for organizing this very, how to say, beautiful event. And I wish you very fruitful discussions and good luck for every one of you. Thanks.
Okay, thank you very much for Dean. And now I would like to ask for welcome speech our Vice Rector, Professor Kęstutis Baltakys.
Good morning, ladies and gentlemen, colleagues, researchers, students, and distinguished guests. Today, I am happy to welcome you to the 3rd International Conference on Information and Software Technology 2024, held here in beautiful city of Kaunas, Lithuania. This year marks a significant milestone for ICIST conference, as we gather for the 30th time to celebrate the advancements in our field, to share knowledge, and to explore new opportunities in information and software technologies. We are living in a unique period where technology, especially artificial intelligence, is rapidly transforming our lives, work environments, and ways of communication. However, as with any technological transformation, we are invited to reflect more deeply on the place of information and software technologies in this new context. Over the years, ICIST has grown into a renowned platform for researchers, practitioners, and industry experts from around the world to come together, exchange ideas, and discuss the latest trends and innovations. We are delighted to see so many of you here representing a diversity and perspectives and expertise that enriches our shared journey towards a more advanced and interconnected technological future. This conference would not have been possible without the generous support and dedication of our partners. I would like to extend my sincere gratitude to the Faculty of Informatics of Kaunas University of Technology and also the Research Council of Lithuania. Also, I would like to express my sincere thanks to the local organizing committee. Daina Gudonine, Jonas Čeponis, Audrius Lopata, Romas Šleževičius, and Lina Revšienė. Please, applause for them. And your contribution have been invaluable in making this event a reality. In conclusion, I encourage you all to take this opportunity to engage with fellow researchers, share your insights, and explore new collaboration. Let's make the most of our time here in Kaunas, not only to advance our scientific research, but also to build friendship and strengthen our collaboration. Once again, welcome to ICIST 2024.
Thank you very much. Thank you for Vice Rector. And let me briefly introduce today's schedule. So we will have keynote speech today after a few minutes, and we will have three sessions today. So the first session will be Intelligent Systems and Software Engineering Advances, Part 1, chaired by Professor Michael Wieczorek. After lunch, we will have the second part of this session, chaired by Professor Zbigniew Marszalek, and then we will have the last session today, special session on cybersecurity, chaired by Associate Professor Šarūnas Grigaliūnas. And tomorrow we'll have keynote speech, as well as a special session on intelligent methods for data analysis and computer-aided software engineering, chaired by me. The second part of this session, chaired by Associate Professor Ilona Veitaitė. And the last session for Friday will be a special session on smart e-learning technologies and applications, chaired by Dr. Ramūnas Kubiliūnas. And I am very thankful for Rector's office, for our Dean's administration for help and support, as well for all the program committee members, for all the reviewers, for all the technical staff, and for all others who supported and contributed this event but did not mention it. And I would like to wish you to have a good time, to enjoy this event. Let's share your contacts, let's share your knowledge, let's share good mood, and thank you very much. And I would like to invite for keynote speech our Professor Florence D'Ambrosi.
Thank you. Do I have to use this? Okay. So here. Is it a problem if I move a little bit? Oh, okay. So thank you very much for the invitation, and thank you to the organizers. Very nice event. I am Florence D'Ambrosi. I am Associate Professor in Medical Technology at University of Stavanger in Norway. And today I will be talking about a little bit of all these things here, so a very long title. Synergy of artificial intelligence of things and sensor technology in human activity recognition for active and assisted living. So we will touch a little bit of all of these items. Okay, so why AI is becoming so famous nowadays? Okay, so which are the main reasons? First reason, big data, and we will see later why. Second reason, computational power. There is a lot of computational power today, and this field is advancing very fast and so on. And third reason, the advances of machine learning. And we saw also the latest Nobel Prizes to two of the main contributors in this field. There is actually another reason for why AI is becoming so famous, and that is because of the money, because people understood that you can make a lot of money with AI and with machine learning and deep learning and so on and so forth. This is a little bit of history of the evolution of AI, starting from Alan Turing and arriving till 2017. So these are the main steps, and the nice things to catch in here is that the algorithmical part of AI have been there since 30, 40, 50 years ago. Okay, but it is becoming so famous only today. And for example, just to look to this, the first neural network was presented in 1986, but we started using it widely in just 10 years ago. If you want to know a little bit more about what happens from 2017, I saw this last night in Kaunas city center, and I saw it starts from 2010 to 2024. So if you just take a walk outside for those who are not living here, and you will have all the complete map. Okay, so why I am talking about AI and why I already mentioned the data and that these algorithms have been there for many, many years. So these are the main breakthroughs in AI. For example, in 1994, we have the first human-level read speech recognition, but the algorithmic part was already there in 84, so 10 years before. But then it was possible to have this application and this breakthrough only because we had this data set, so this amount of data that we used to model this algorithm. The same thing happens for all the other algorithms, basically. If you see here, the algorithms, they were proposed many, many years earlier, and then they became so famous only after, so in this case, this is when we had the breakthrough, only after some big data set or learning platform was made available. Okay, so yes, AI is good, but it's only because we had data, and a really big amount of data. Where is this data coming from? Okay, so these are the main sources of data today. Open data provided by institutions, governments, and so on. Social media data, and all of us knows what I mean with this. Web data, corporate data, images, video, audio data, retail, e-commerce, and so on and so forth. But when I started in the title of my presentation, I had AI, I had IoT, I had sensors, I had human activity recognition, and so on and so forth. One of the main components here actually is sensors. And this is also my main field, sensing systems in medical technology. Okay, why are we discussing about sensors today? And what are sensors? So first of all, what are sensors and what is a sensing technology? Everyone here knows what these devices are. So this is a smartwatch, TicWatch actually, this one. This is a Raspberry Pi, probably everyone here knows. Everyone knows definitely this one, Apple phone. And this is a Nordic Thingy 52 semiconductor that is actually this one that you see here. A sensor is basically the, let's say, basic electronic component that measures physical properties and transforms them to electrical signals. So temperature, for example, humidity, radiations, magnetic fields, and so on and so forth. A sensing technology or a sensing platform is the overall electronic system that makes this information detected by the sensors into readable to us, so understandable to us. Okay? So these are two basic concepts. Now, again, why are we talking about sensors and why sensors are so important for us and also for AI in this case? This is the trend of sensor number in the world. And we see here we have 62 billion of sensors in the world today for a total revenue market of 96 or $97 billion. The other important thing here is that if you just think about these sensors, if each of them will sample at a frequency of 10 hertz and will give us a 32-bit value or payload, we will be basically collecting every second almost 2 terabytes of data just for these sensors. 2 terabytes of information every second. From another perspective, we are living somewhere here. This is the total area of the Earth, so 510 trillions of meters square. This is the land part, 148 trillions of meters square. This is the habitable part, where we are actually able to live, 64 trillions of meters square. And if we map those number of sensors that we saw earlier, what we see that today, or actually next year, in a few months, we will have one sensor every 852 meters square. And we can use the information from this sensor to detect what is happening in that area. And by 2050, we will have one sensor every 250 meters square, and by 2020, or 2100, we will have one sensor every 150 meters square. This is why sensor technology is becoming more and more pervasive and ubiquitous. Okay, another numbers, and I will collect again, connect this to AI, sensors, human activity recognition, and active and assisted living. And when I talk about active and assisted living, one of the main issues that we are going to have in the future is the aging of population. This is the trend of aging of population. So you see here in 1980, we had 0.4 billion of people aged over 65 years old. In 2050, we will have more than 2 billion people aged over 65 years old. And as you also see, this number is increasing a little bit, but these other numbers are a little bit getting slower and smaller. Okay? The other issue in particular for us is that we will see later, Italy and Finland, very near here, here are the most, let's say, old countries in the world, except Japan. If we see it on more detail, this is the aging of population map with people over 65 years old. And these are the first 32, let's say, oldest countries with the oldest populations. And among these 32, only Canada and Japan are outside. All the others are European countries, as you can see. And actually, Lithuania is here. So in Lithuania, 19.8% of the population is already over 65 years old, for a total of 550,000 people over 65 years old. And the other bigger problem is that more than 50% of this 19.8 is over 75, okay? And this will create a lot of issues for us because we will need, these people will need more help. In particular, also the system will need more help. So we will need more doctors, more nurses, and more caregivers. And I was discussing earlier what happened yesterday in Italy. The medical study program became open to everyone. Everyone can enroll without doing an exam. And this is because of these issues. We don't have enough doctors, we don't have enough nurses, enough caregivers, and so on and so forth. The workload of these people is actually becoming high and high and high. So they are spending more time in the hospitals, in the care homes, and so on and so forth. So what we are trying to do today is we are trying to go also from a care home perspective. So care homes, nursing homes, okay, for elderly people and people with special needs, to home care, because we want them, since we cannot design so many care homes, we want these people to live at home autonomously and actively in their home as long as possible and shift the time when they are actually going to the care homes. And to do this, we need to map their functional and behavioral domains, so how their motor part works and also how their mental part works. And we will use AI to do this. Some other issues that we will have related to this are related to the cost for healthcare systems. This is the projection of how the cost will increase in the USA, for example. And also from a social point of view, the elderly needs will increase, will double in the next 20 years. That means that, again, we will need more dedicated healthcare structures, so more money from the government, more money from us to be invested in this field. But also we, as family members, will have to spend more time with our parents, with our grandparents, to care about them. Okay, so this is, again, we will do this, but it's still time that we will have to take out from our children, for example. Okay? So what are we doing in this context? We have already started working in this field many years ago. We started using monitoring systems and telemedicine systems and so on and so forth. At a certain point, we also, or the European Union, started this program called Ambient Assisted Living, AAL. Okay. So after this, we entered the era of big data and IoT. So we started discussing about IoT in healthcare. And then this became IoT for healthcare, so dedicated for it. And nowadays we are discussing about Internet of Medical Things. So a dedicated Internet of Medical Things with precise standards, with precise requirements, and so on, certifications and so on. However, the biggest issue here is that, and we notice this later, is that the ambient assisted living research area had a specific goal of creating an environment which assists people in daily life, which do the things that elderly, for example, should do on their own. These systems will do these behaviors, will do these activities on their behalf, okay? But this was not so good, because that means that these people, they will lose their autonomy. They started, for example, designing robots, which had to do some things on behalf of the elderly. But then they saw a degradation of the functional and behavior domain of these people. It's the same that is happening when elderly people go in the care homes, okay? The nurses will do everything on their behalf, and they will just be there sitting and laying down and eating. And they will lose their functional and behavioral domain. And what happens normally is after 5 to 6 years, they actually will die, okay? So what we are trying to do, we are trying to go towards active and assisted living. So we want them to stay at home, live as long as possible in their houses in an active way. So instead of doing things on their behalf, we want them to do their things, to learn new behaviors, and to train themselves. For example, a person over 75, they normally lose the sense of needing to drink water. Okay, so we have to teach them to drink water. They have to remember them, to remind them that they have to drink water. So this is a behavior that they need to integrate. Okay, so this is just an example, but there are plenty of these type of examples. So the goal here is to maintain them in their house as much as possible before going to the care home. Okay. Now, this is when artificial intelligence of things enters in. Okay, to put a little bit together all these components, artificial intelligence of things is a combination of AI and IoT, and the goal is to create more efficient IoT operations, improve human-machine interactions, and enhance data management and analysis. So this is the goal, and this is enabled today because we had decreasing cost of CPUs and memories, we have convergence of IT and operational technologies, we had big data and clouding capabilities, increased number of devices. Everyone here has a smartphone, a smartwatch, or a smart house, or Alexa at home, or Google Home at home, and so on and so forth. So we are going to use all these things. Decreased cost of communication, for sure, and also a lot of investments in this field. What is AIoT for healthcare about? So this is an overview. So you see here now today, when I talk about artificial intelligence of things, I am mainly concerned about this layer here. So embedding computing layer. Anyone here knows what TinyML is? Anyone knows what TinyML is? Tiny machine learning? Okay. So tiny machine learning is basically that new technology that is becoming very famous nowadays that enables all these small things that you see here to become intelligent. So instead of going up here with the computation and the AI capabilities and the intelligence, we can create AI models on the actual device, so on my smartwatch, on my smart ring, or on my phone, but also even dedicated sensors that you wear in your shoes or in your clothes that are able to recognize specific context of daily life. Okay, and we will see some examples later. But again, this is not only here, the AIoT, but it goes over all the hierarchy here. So we have embedded computing layer with our things that we can use and are intelligent. Then we go with different communication technologies to the edge layer, for example, phones, tablets, computers, routers, because we will see that the routers are more than intelligent today. And then we have the cloud part, in which we have big data centers, big servers, computing, spending a lot of energy, and so on. And there we apply and we create our dedicated healthcare application scenarios. And you see here, for example, dementia care, stroke recovery, breast cancer, COVID management, and so on and so forth. Where are we using IoT? We are using it for health monitoring. So monitoring people at home, monitoring people in the workplace, in industry, to monitor how the worker is behaving, if the worker is okay, if the elderly is okay, and so on and so forth. To perform diagnosis about specific diseases, okay, neurodegenerative diseases, chronic diseases, and so on and so forth. Prognosis and disease discoveries, and so on, explainability and other things. what we are using, sensors and devices, starting from wearables and environmental sensors. What we are using, communication technologies, machine learning, CNNs, RNNs, SVMs, which are all components or technologies that can run on very small devices. Just going back here, I will make an example later, but just think about that nowadays you can have a very small TinyML model which can recognize very complex context of daily life, like speech analysis or also gait analysis and so on and so forth, with a model which has a size of 20 kilobytes. It needs 20 kilobytes of memory. It needs 10 kilobytes of RAM memory and has an inference time of 1 millisecond. So in 1 millisecond, he can recognize a very specific behavior of people. What are we then doing in this context of AIoT, sensors, and active and assisted living? We are working on virtual coaching systems for people with special needs, like, for example, the elderly. So the virtual coaching system is a separate system for this category of people, which is not assisting them, but is training them to learn new behaviors and to avoid unwanted behaviors, so risky behaviors. My grandpa drinks too many coffees. Okay, I can recognize that he's drinking too many coffees, and I block the coffee machine on providing coffee, okay? Or he's drinking too much rakia. Okay, I am from Albania, so we love rakia. And so I can understand this, I can recognize this, so I stop him from drinking rakia, okay? What are we actually using also? It's not just technology, it's also psychological things. So we are using a concept of extended mind, that is a psychological concept, that says that the brain or the memory of a people is not what you have in the skull. It's not only that, your memory. It's also the environment where you live. It's also the objects that you live, that you use normally. So what we are doing, we are transforming everything today into smart. Everything, or the things that we normally use, the bottle of water, my preferred cup, my key of the office or of the house, my car, my home, and so on, everything is becoming smart. So we need not only what we remember, what we need also the environment around us to implement better and better coaching systems. Then we use IoT solutions to recognize the daily activities of these people and then implement virtual coaching system. And this is where we will see a lot of results now, or a few of results now from my research activity about virtual coaching systems. So where do we start? We start from this context today. So now I bet how much money you want that everyone here has a phone, a smartphone, okay, or at least a smartwatch. So we can already detect a lot of information from you. Just think, for example, that with a smartwatch, with an accelerometer, you can actually understand what someone is typing on the keyboard, okay? That type of sensitivity. So it's a little bit scary, and the security researchers are working on it, but that is the type of sensitivity that you can get today. And we will see later that we have also smart sensors like the Wi-Fi network in here, and we can use radio signals to recognize what people is doing, okay? And we will see some videos. So this is where we are living, a lot of sensors, and this means a lot of data, okay? And then with this data, what we need actually, we need more specific AI or machine learning techniques or data analytics technique to recognize these activities of daily life, to implement the virtual coaching system. So this is a dedicated research area, human activity recognition, that is very close to what AI is and what AI or how AI works. So which is the goal here? The goal is we want to recognize human activities. Now, who has a smartwatch here already knows that their smartwatch can recognize the number of steps, if you are running or not, if you are sleeping or not, if you are sitting down or not, and so on and so forth. But this is not enough, actually, because we want to recognize more specific things. We want to recognize if you are washing your dishes at home, if you are an elderly person. We want to recognize if you are washing your teeth. We want to recognize if you are eating. We want to recognize other specific things. Are you doing the laundry? Are you washing yourself? Because this helps a lot, for example, to diagnose possibility of having mild cognitive impairment. So this is what we want to recognize. To recognize this, we need human activity recognition models, which are basically some AI model trained on some specific data. And this data is basically collected through the sensors that I mentioned. So we have environmental sensors inside the room, temperature, humidity, CO2 level. Just for example, with a CO2 level sensor, you can recognize how many people are in this room. Okay, because every one of us generates a certain amount of CO2 level of CO2, and then we can recognize it. Inertial sensors, wearables, smartwatch, the simple one, but also dedicated things. Smart glasses nowadays, very famous because of the Meta smart glasses. Physiological sensors, which are heart rate monitor, oxygen level, and so on and so forth. Then what we do data annotation. Have anyone here ever had to annotate data for AI or machine learning applications? Okay, when I was working at University of Florida, we had a big room with master students and bachelor students sitting there 8 hours per day annotating video, frame by frame, sitting there and annotating video. Then we have all the classic performance or pre-processing parts, signal processing parts before going to the machine learning, deep learning, or AI models that we want to design. Now, this part here actually is becoming very easy these days. A lot of frameworks, a lot of already existing methodologies, okay, very fast in performing the pre-processing and training and testing and so on and so forth. So normally to design this human activity recognition system, you need 20% of your time. Then you need 70% of your time in annotating data. Personal experience, I started a project on Parkinson's disease that was published last week in Nature Parkinson's Disease Journal. That project started in 2017 when I was in second year of PhD, okay? And it concluded just 3 months ago when we submitted the article. All this work was delayed because the neurologist had to annotate the data from the Parkinsonians, okay? And then this is easy today. You can just write a very easy Android app and you can collect this data in just half a day, okay? This now is becoming a central component for many fields, so IoT, smart cities, smart homes, and so on. And then when it comes to actual what we do in medical technology, is becoming a central field in Internet of Medical Things and artificial intelligence of things. Now, you know, those of you who work in this field, that is not an easy task, because when you create some pre-processing and AI training and testing approach, you need to do a lot of things here. So there are different steps, different techniques. These are just a very small subset, but here the area of exploration is huge, okay? But still, we are trying to do this. So this is, for example, an open framework that we have called BHAR, Baseline Human Activity Recognition, that you can just use, give the data and input, and it will generate some good model for you. However, when we work with clinicians, we cannot ask them to design this. And we don't have the time to sit there and design every time what they need. Okay, so we are providing them tools to do this on their own. Because we don't have time, these pipelines are difficult to generate, and so on and so forth. So what we are doing here, we are moving towards the low-code, no-code context. Anyone have ever heard about low-code, no-code? Great. So the idea here is that we provide some easy-to-use platforms to actually the doctors, and they can design their pipelines by just drag and dropping things and create some dedicated analysis and so on and so forth. And for example, one of the most used let's say low-code, no-code, still for us, not for clinicals, are these two. Have everyone ever heard about these two? Age Impulse and Newton AI. Okay, so with these two, basically, you just need, for example, a Nordic Thingy 53. It's one of the boxes I showed in the beginning. It costs 30 euros or less. And basically, in half an hour, you can have a system that collects data from you, sends the data to the cloud. In there, you can use a low-code, no-code platform to create an AI model that recognizes some activities of daily life from you and deploy the model directly on the node. And then you can recognize what is happening to you on the actual sensor instead of going on the cloud. Half an hour. I did this last week for my students. I showed them in half an hour you can recognize if you are walking, for example, if you are waving your hand, if you are sitting down, or if you are typing on the keyboard. Okay, half an hour, we were able to do this. We collected 4 minutes of data. We didn't need more. Okay, so we are here today. We are working a lot in this type of direction. Now, these are commercial available solutions, but we are working also on research part on our own. So how we are using then AIoT, okay, artificial intelligence of things, are algorithms for implementing virtual coaching systems. Now, this is an example of sensors that we use. This is $3 sensor, including an accelerometer, gyroscope, and magnetometer from Nordic Semiconductor, basically coin size. We normally cover them with some rubber and adhesive, so you can attach them on the objects of daily life, and from that moment, that object will become smart and will be able to communicate with you, or with your smartwatch, or with your smartphone. And then you can transform all the objects of daily life into smart, basically. So imagine to have a smart bottle. I can recognize if my grandpa is drinking enough water or not, okay? And how regularly he drinks. I can recognize when my grandpa is putting on his shoes and he's going outside the house with or without the shoes. I can recognize if they are washing their hands. I can recognize if they are washing their teeth in the morning. Okay, so I can, in this case, map their behavior. And then if I see an anomaly in their behavior, I can tell to the clinicians, look, that my grandpa is having an anomaly in their behavior. Okay, so can you please check on him and see if he's in some early stage of mild cognitive impairment, which basically leads to Alzheimer. Okay, so this is just an example. We have done a lot of work in this direction, so we have some publications about specific things. And then we have this other part related to Parkinson's disease. So everyone here, I think, knows what Parkinson's disease is, but you don't know actually which are the main symptoms of Parkinson's disease. Okay, so Parkinson has two main categories of symptoms: motor symptoms, so those that you actually see, for example, tremor, and they have also non-motor symptoms, which are more related to the cognition of these people. For example, sleeping disturbances, gambling. You know, there was a medicine that they used to use which actually enhanced the need to gamble. So Parkinsonians, they were going to the slot machine and they were spending a lot of money there. Okay, so this was a non-motor symptom. One of the most cumbersome and most dangerous motor symptoms in this case is the freezing of gait. Okay, the freezing of gait is this symptom that you will see here. So this person is a Parkinsonian with 7 or 8 years of diagnosis. What happens is that he's normally walking and now he's freezed. He cannot walk anymore. His brain is telling to his feet, go ahead, he doesn't work. They not respond. So what he does, he moves like this, and this can have a duration that goes from 100 milliseconds to 3 minutes, and 3 minutes of doing like this, they fall down and they have higher injuries. Okay? So you see, this happens basically when they have to turn, normally, when they have to go through a very straight area, so like this. If they have to go here, they will block. And if they have to move and they have a change of the pattern, like here, red to white, this will disturb them and they will block, they will freeze. Okay? So this is what they do, and this is what we want from them. We want them to move freely in their daily life. Okay? So this is the same Parkinsonian 5 minutes after, and he is not blocking here. And I will show you later why he's not blocking. Okay? So you see, he just goes through without any issue. What are we doing now to help them in this context? First of all, we can give them medication, levodopa. Okay? But we saw that levodopa, after some years of usage, because this is a medicine that they will have to use for 10 to 20 to 25 years, this will lose the effect, and they will need more and more and more and more and more and more. Okay? The other thing that we can do without using medication, we can give them some external stimulations. For example, we can stimulate them through visual stimulation, showing them something. We can stimulate them through tactile. I have seen, for example, a Parkinsonian, when he was freeze, his wife was going to touch him here, and he will unfreeze and will go directly. Okay? And also audio, a military march, like 1, 2, 1, 2, 1, 2, because they synchronize their walking pattern with the stimulation. And this happens also for the visual and also for the tactile. Stimulation methods are this one. So what they do, for example, they mount some lasers on their shoes. The laser, this right one, will project some light there, and this is where they are going to put their feet. And then this laser will project something here, and they will do like this. So this is a way of stimulating. Another way is, yes, to have earpods with audio, 1, 2, 1, 2, 1, 2, a military march, beep, 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 and they will concentrate the walking pattern with their stimulation. But still this, they saw that time to time, after years, they will lose this because the continuous stimulation is not good. They will get more distracted about that. So we cannot go for continuous stimulation. This one was one, how do you call it? You see, one support approach with light, which was projecting light, or this was a belt, basically, which was projecting light in front. So they know that they have to put their feet there. Okay, so this was the old way of doing this thing. So what we did in this context, we designed a body-arm network, okay, with a data aggregator, which was basically a smartphone. We can connect to these data aggregators smart glasses with monitoring capabilities and stimulation capabilities. Okay, so light stimulation, visual stimulation, bone conducting vibration to have tactile stimulation, smartwatch to have vibration on the wrist, and also different nodes, which are standalone nodes that we normally put in the back, here, which are the most informative points of the body. Even if the problem with Parkinsonians is that it is an asymmetric disease, so it can take one part of the body or the other, and it changes a lot from people to people. So it's a very difficult task. So this is why we created a big body-arm network which can integrate 11 data collection points, or 12, sorry, and we want to collect data and understand which is the best position for every person. And what we do, for example, the paper that I said was accepted last week, we collected data from Parkinsonians on these 4 positions, and what they have to do different tests, and one of the most used tests in clinical practice is they have to start from a sitting position, and normally what happens when they stand up, they block. They cannot move. So they are in freeze. And then they start walking. They have a lower probability of freezing when they are walking in a straight, but they have a high probability when they are turning here. This is a very high probability of freeze. And then they go back and they sit down and they again freeze. Or again, we test them in going through doorways and they will freeze. Or we test them, we load them, the cognitive part, we load them, we ask them to go back and count from 40 to 0 back, and this will increase the possibility of freezing and so on and so forth. Okay? But then what we do with human activity recognition and these things, we design AI models or HAR models which are able to predict the freezing of gait. Okay, so what happens here, we designed a model, for example, in this one. This was an older article, but we have more recent ones. And what happens, this was the previous video without stimulation and without AI recognition. And you see he was wearing, in this case, a node on his, now here, on the left arm. And then here, we had the AI model recognizing the movement, okay, the accelerometer, gyroscope, and magnetic field, so the orientation. And every time we were able to see that in the next 1 or 2 seconds there will be a freeze, we were making the node vibrate with his walking frequency. And then this is why in this case, this elderly was not freezing. Okay, this is what we mean with AIoT and HAR for virtual coaching systems. So this is a virtual coaching system that they can use in daily life. Now, there is a lot in human activity recognition and in sensing technologies here. You see we have biosensors, implantable sensors, radio signals, and so on and so forth. And I would like to concentrate a little bit here. This is a new frontier when it comes to sensing technologies. The goal here is that you have an access point at home. We have radio waves, which are emitted in the environment. And basically, these radio waves will change based on the environment. Okay, so if you move, the radio wave will change. If you don't move, the radio wave will have a certain pattern, so on and so forth. So the idea here today is that you can use these radio wave changes to recognize what is happening. So these people, they don't need to wear anything. They just need to go in the environment, and the radio waves of your access point will already give this information to you. In this case, we have designed this tool, and we will show it later. It's freely available online. But what we are doing there is the following, and I am almost done then. I have a little bit of time. Okay, so this is about Wi-Fi sensing. So we recognize the propagation pattern of radio signals, okay, to recognize what is happening in the room. For example, this is Christian, one of our PhD students. He is using the tool to recognize every time he's breathing. Okay, so his chest was moving, and we can recognize through the radio waves that his chest was moving, so he's breathing. Okay? We can recognize when they are inside the room and the activity. We can recognize how many people are inside the room, and what we need is just an access point, which emits signals and reads the signals, and all the AI is happening on here. Okay? We can recognize the gait analysis, so instead of wearing wearables in a specific environment, we can recognize the steps phase of a person just using the radio signals of the environment, so they don't need to wear anything. This is, you can do also a lot of gesture recognition and so on and so forth. So you can use this also to create dedicated interaction approaches. Now, this can be done very, very accurately with other type of technologies, not Wi-Fi. For example, you can go on millimeter wave or ultra wideband, and you can recognize heartbeat of people. You can recognize very specific behaviors of these people. But we want to do this in a cheap way and use what we already have instead of buying other technologies. And everything is done through AI. So what we actually did here, we designed this tool that can perceive many, many access point networks, because you know nowadays probably in here we have 30 access points visible, and we have signals for first 30 of them. And then we need basically a Raspberry Pi. So now it's actually a little bit costly. It's difficult to find, but or any other access point, as you saw, router as you saw earlier. And what we can do, we can basically recognize all these networks, and we can measure or we can observe the channel state information of these networks, how they change and why are they changing. And then in the same tool, what you can do, you can perceive the data and perform your data management. You can integrate your own data pre-processing steps and pre-process the signal, because still you need some cleaning of the signal, store the data and so on, visualize the data as you see here, and then you can train the models, different heart models based on the context. Okay, and then you can use the model to recognize what is actually happening. So the example here is, if you want to know if your neighbor upstairs is at home or not, you can do this at home on your own. Okay? What actually happened is, who knows, Verizon, the telecom communication company in USA, what they are now providing as a system, in addition to the communication part, they are providing routers with AI-enabled capabilities, which is able to recognize if in the house is someone that is not part of the family. Okay, so you install the access point, it says to you, okay, train the system with all the family members in the house, you train the system, and then from that day, every time someone new enters, they will recognize it. And they recognize this person based on the body shape and also on the walking style. That is one of the main features, the fingerprints that everyone here has. Everyone here moves in a different way from the others. Okay? Just an example of what is happening in this direction. What is wireless eye? You can find it online, open source. So what we do is here you can visualize the status of the different channels or access points that you have here. You can select here one of or more access points in the environment. Okay. Here is the channel state information. Here is the phase of the signal, and you can have multiple access points. Here is the received signal strength indicator, which is like another information related to the signal strength that you receive. And here are your classifiers, your AI or HAR models. So basically the tool gives you the possibility to train different type of models. For example, an SVM model, a machine learning model, a CNN model, an NRNN model, and so on, that you design. And then you can deploy the model inside the tool, and you will be able to visualize which model is performing better, okay, in real time. So, and this is easy. We did this because we saw that to do this type of work, you need to have a lot of knowledge from actual telecommunication and radio physics part to computer science to programmer and so on and so forth. What we did here, we did everything in one tool, so everyone can do this without having any specific or any knowledge about the different fields. You just need to have some good knowledge of AI part. Okay? And to conclude, other application scenarios that we are using. So when we have routers or radio signal sensing approaches or wearable sensing approaches and other type of approaches actually, and to design human activity recognition for virtual coaching. So we already saw the Parkinson part, but we are also using this to monitor daily life of people with Alzheimer or mild cognitive impairment or elderly people in general. Now we have a big project with Oslo municipality where we monitor elderly in the care homes for years in order to find any anomaly in their behavior, so to recognize possible mild cognitive impairment in the future and so on and so forth. Other things, we worked a few years ago with women who undergo chemotherapy. And one of the issues after chemotherapy is chemotherapy-induced peripheral neuropathy, so they lose the sensibility in the peripheral arms or feet. And what happens is that if they put their hand on a very hot item, they will not feel it. So they will get burned, but they will not feel it. So we wanted to recognize this through wearables before that this became a very big issue. Then virtual coaching for elderly people. They have to drink enough. They have to do specific activities. They have to wash their teeth in the morning and in the night. They have to have breakfast and so on and so forth. We just published also an article about safety using these systems in Industry 4.0. So recognize the status of the worker, if they are feeling well or not, if they have an anomaly, if they are behaving as usual, if they are doing a risky activity that can impact on their life and also in the machineries that they use. And the goal for the future is the implementation of the human digital twin. So if we can have a digital twin of the functional domain and behavior domain of these people, we can use the digital twin to predict, but also to prevent. Okay, and so we can simulate how the people will behave based on a treatment that we will provide or a therapy that we will provide. Yeah, so yeah, this is the easy one, indoor positioning. So this is the easy things to do here. That's all from my side. Thank you very much. I hope you enjoyed.
Thank you very much for very interesting presentations. Do we have questions? Okay.
Thank you very much. That was super interesting. However, and I play you forgiveness in advance. My inner data protection personality is coming to the front. Beside the obvious military application or something like wireless eye, because if I want to target someone inside a house or a building, I can do that using the Wi-Fi without anything thermal sensor or anything more complicated than that. But are we thinking in the context of the research of how we build those data sets? Do we inform the persons about their personal data? It is obviously it is data about biometric data. So in Europe, you understand the problems with that. Is that a context that it is taken into consideration? Because those data sets then are published, et cetera, et cetera. So the application, of course, is very useful and for people and for the elderly and so on and so forth. But are we considering those aspects in the research part?
So definitely, first of all, thank you for the question. I was expecting that question actually, and it is nice to be here also because you know these issues better than me. So I normally am more concerned about this part. So when it comes to the usage of wireless radio signals, now actually the new protocols, the wireless protocols that will come out, they are already working on how to obfuscate these capabilities on these devices. Actually today, not all the devices provide you the capability to do this. You need some specific antennas and then you can do this. So not every router or access point can do this, or not every Raspberry Pi. Just a specific model that you have to know which one. First of all, concerning the regulation part, at least when it comes to research, everything that we do undergoes ethical committee approval, and approval also from the participants in this case. So actually we need to prepare at least, or to put aside at least 1 year of ethical committee interactions before starting doing any tests with Parkinsonians or with any other type of cohorts of people that we know. So from a research part, I can say you that we do this in a very safe and privacy-concerned way. From a real-life part, I don't know if everyone is doing that. So that's up to every researcher when they have to do this type of tests.
Yeah, I'm also thinking, I'm sure that the research part is covered by a huge amount of experts and lawyers and university departments for that purpose, but I'm also thinking about when these things will be incorporated in consumer products, because you need to make users understand what they are sharing, how they are sharing, because it's remotely, of course, because you have to do the AI part mostly remotely. So yeah, not just that. My inner yeah, also my inner standardization persona in data protection is cringing a bit, because it's very hard to make understand people the implications. That's something I will talk about security as well, but
so there are movements.
It's hard to communicate. Yeah,
there are movements today in which actually what is happening is that the owner of the data will be the user, and the user will accept or not to sell his data to the corporate which is using, for example.
Well, it's not a movement; it's European law.
Yeah, it's European. Yeah, but it's
Europe.
Yeah. So there is I don't remember the business-related word for this. But yeah, actually today, what we are also doing with some work that we are doing is like to understand the elderly people that if they are collecting or using some technology from some companies, they can require or request to these companies to be paid for the data that they are transmitting, or they just stop the data in there on the edge, and then from there they will not go out. That is the idea that we are also working on. And
it's even more complicated than that when AI models we are talking about ML models, because theoretically, and this is probably a limitation of our regulation at the moment, if my data is used to train the model, on paper you have the right to ask the person who's managing the data to erase it. So that means on paper at least, and I will leave it to the lawyers, to retrain the model without taking out that single records and items.
So that will be difficult.
Yeah, it's an interaction that is going to be very complicated.
However, we are now very focused, or what the research area is now very focused is federated learning. Yeah. Okay, so that's made on purpose to avoid any possible risk related to data leak or the capability to understand the data, basically. And this is happening all on the edge. So in that case, from a privacy part and a data-related part, I think we are a little bit more safe. But still, the issue is what you said. So normally, we had a problem with tests that we did in Verona University in Italy. We collected data, we did all the work, we did the videos for annotation, and then this girl, she was a test related to sports activity. She came and she said, I don't want any more my data in there. And we were like, okay. And but you have signed everything. Yeah, but I can reconsider it. I talked with a lawyer. Yeah, but you have signed, you know.
No, but unfortunately, the law is like exactly like that. So I can reconsider.
Yeah.
So if you have trained already the model, that's a huge issue, and I think we should talk about the GDPR at some point. On that.
Yeah, but definitely. But this is why I said I knew that I will have these questions.
On paper, according to the law, she was right. So that you understand the problems there.
Yeah, definitely.
Okay, thank you very much. More questions?
Yeah, thank you, Alexandra, that you take this question from my mouth, because I'm also from the cybersecurity area. So instead of asking, this cyber-related question, I would like to ask you more philosophical question, because you are collecting a lot of data, which can predict even what we will, what issue we will have with our healthcare. Imagine the situation, how it could increase the insurance, I mean the health insurance, if they get this data, which will be obviously shared by me, and they can predict that probably I will get sick in 2 or 3 weeks or month. It is one question. And second question, how it will impact the probably my employee status if I get if I decide to get to the new job, and they will get this data and can predict that probably I will be there like for the 6 months only, because I will be sick after 6 months. Yeah, so that's my philosophical question to you.
Yeah, so first of all, thank you. Now, the idea here is that, as Alessandro was saying, we have GDPR, we have a lot of regulations in Europe that will avoid, at least at the moment, that we share this data without our consent. But my fear here is that you will somehow be obligated to share this data, you as a person, because they will put some constraints to you. So that is my only fear in this case. Like, you will have a new job, but they say, you want this job, but we want this data from you, and we will give you a higher salary. And then you will be like, do I want a higher salary or not? So yeah, so that's my fear, because it's becoming like what happens with Facebook and Instagram a few months ago or 1 year ago. At a certain point, all of us in Europe, we received a notification saying, you pay or you are consent to share the data. And everyone was, I don't know if anyone here was paying to not share the data, but all people.
There were already cases on that one, and the authorities say, Meta, you cannot do that.
Yeah,
Sure.
but we received these notifications about the data treatment and so on. Yeah.
They will do it anyway, so it's interesting to see what is going to happen. But they are going to do it anyway, Meta and the other big techs, of course. But still, it's going to be interesting, the power struggle there between Europe and...
That's why I'm saying, like, this will be more on the
open,
regulation part. It's not on our side as scientists or as companies which will collect the data. Because again, now I am opening a company in Norway, and the goal is I collect the data, I give you the capability to do this type of predictions or anomaly detections, but then I just do that. Then it's you, company, who want to use this, who will handle this with your clients, as you said, insurance companies, or, for example, what insurance companies for cars, at least, are doing or have been doing in the last years. They are like, okay, install this black box on your car, and we will give you a reduction of 30 euros on your year insurance. But then what I noticed with that black box, they can map where you are, they can map the style of driving you have, they can recognize if you are a male who is driving, if it's a female, if it's a young teenager or 18 years old at least, or if you are an old granny who drives at 10 kilometers per hour. And then they can also say, it happened to me actually 2 years ago. I had a small accident and I filled in the documents. I had an accident in the Verona airport in Italy. But when I filled the document, I wrote the hour, 18, and the lady who took the document, she read it 13. And she was like, this request is rejected because when you had the accident, your car was not at the Verona airport that you wrote. It is at the University of Verona. I was like, no, it's impossible. I was there. And she was like, yeah, but you have written here. You see on the GPS of the car, I see that it was parked there. So I think it will be, yeah. So it's a little bit difficult. It's a very philosophical questions, and it's difficult to understand. And I think it will strongly be related to what we as a community will require, because I'm afraid that most of the population will say, I don't care, I just need this. Okay, and then me and you, we will be like, okay, I don't want this, but we will be the minority. So it will be a little bit difficult to.
Okay, we have more questions. Thank you.
Thank you for your presentation. I was just wondering, you mentioned that you can encourage some behaviors, you can provide stimuli when a person is blocked. You were also talking about blocking some behaviors. So how do you go about it without physically restraining the person or just blocking their coffee machine or something?
Yeah, but that was just an example. You know, we don't have control of the coffee machine till now. But in the future, who knows? So that was just an example. What the goal there is that we give some alerts to the elderly, and we say, look, you have already taken 3 coffees, and it's 10 o'clock in the morning. So pay attention to this. And if they keep doing this, this information will end up to the caregiver or to the doctor, who will take into account this when they will talk with the patient. That was the goal. Other type of blocking is not actually blocking. It's like you go out from the house without the jacket, and outside here today is -1. Then we just say, okay, before going out, look that it is -1 outside. I think that it's better if you are wearing a jacket instead of going outside with a short T-shirt. You know? So this type of blocking. Okay. That was it.
Thank you.
Okay, thank you. More questions? Okay, so maybe I would like to ask the last question. Oh, sorry, I didn't saw. Oh, excuse me.
You're running too fast.
Yeah. Okay.
It will be a little bit short question without philosophical advancements. So thank you for your presentation. And you were talking about all the external sensors, but as you said, every one of us has some sensors in our pocket right now. Do you think any advancements on that side, maybe you don't need external sensors, and the computer we have in our pocket would progress to include all the information that we need and also send the information that we need? How do you think the progression of the mobile phones will work with your field?
Okay, so you are saying that, thanks for the question, first of all, but you are saying that your idea is that will we be able to use only the phone for everything, basically? So the phone has very good capabilities of recognizing a lot of things, but there are still some drawbacks when it comes to specific, in this case, medical applications. Again, just think about the fact that your phone, I have my phone now in my pocket, and this is the orientation of my phone, this facing towards my body. If I change the orientation, if I change the facing side, it will still create some noise to me. So it will not be so good for my models that I have trained into it. So for some specific things, yes, the phone is the main source of information that you can use today. For some other specific things, you will need some retraining at least. On the other side, again, the phone has a lot of capabilities. For example, the same firmware that we were using for wireless eye, there are some phones, actually not new ones, but old ones like Nexus 5. With the Nexus 5, you were able to recognize and do the same things with the channel state information with radio signals. So that's also something that we should consider. But again, nowadays they are trying to limit all these things actually. They are not thinking about having more accurate phones or whatever. They are actually thinking more about how to limit the capability of phones to detect things. For example, there have been studies in which you put your phone on your desk, and then you can write on your keyboard, and then they can recognize what you are typing on your keyboard. Okay? So we don't want these things. That's definitely what we don't want. So you have a lot of capabilities, but normally now today, due to security constraints, we are trying to mitigate the capabilities of the phone at least. But then you have today the Meta glasses, which are doing more than that, because they are basically recording everything that you are doing your life with cameras and so on. So that's still what you ask it. So it will be a big mess in the future, and we will have to fight about this part.
Okay, thank you. And the last question, it's kind of philosophical one as well. So, it is, in general, it is a risk that people, human beings, will become kind of robots controlled by AI every minute, every second through various, mobile devices, smart devices, gadgets, and so on. And every day, every minute, and every second, you will be controlled. Open the bottle, drink the water, close the bottle, please start taking the meal, stop, enough, and then so on, so on, so on. So what do you think? Maybe it is risk that it could initiate I don't know, physiological problems or something?
I think those problems have already started. So by using any type of platform, you have now addicted people. The addiction on smart devices is actually a clinical diagnosis in the USA and many countries. So this is something that you have already. You have addicted kids, you have addicted elderlies. My dad is all time on Facebook. Okay, so I used to do, okay, what are you doing? Are you working for Facebook or what? So it's not addicted, but every time it's like clicking or writing something on Facebook, and I receive notifications about, Rustem, my dad is writing this. I went, oh my God. So, and he also passed a lot of philosophical questions and stuff, but still he uses it.
Okay, thank you very much. Thank you for. Okay, so now we will have a coffee break, and we'll start work into the sections after half an hour. Thank you. Okay, dear colleagues, so now we're starting the special session on intelligent systems and software engineering advances, chaired by Professor Michael Wieczorek.
Hello. Welcome on the first session of this conference. It is a special session on Intelligent Systems and Software Engineering Advances Part 1. Welcome everyone. We will have 4 presenters. The first technical question is, of course, are all 4 of them connected and can hear us and are ready for the presentation? Okay, and if everyone is connected, then the first presenter will be Katarzyna Wiltos. She will have a presentation about impact of future standardization on classification process using PCA and SVM algorithms. I've heard she is online and connected. Then, Katarzyna, if you are ready, you can start your presentation.
I'm sorry, can you hear me?
Hello, yes, I can hear you. Do you hear me?
Okay. Yes. Can I share my presentation?
Yes, you can share. We are not seeing it yet. One moment.
Okay.
Did you click on share your screen? Yes?
Yes. I can start now, right?
Okay.
Good morning, everyone. My name is Katarzyna Wiltos, and today I will have the pleasure to present my paper, in which I investigate the impact of feature standardization using a Z-score method on the classification process using the principal component analysis and support vector machine algorithms. Before delving into the details of this idea, let's briefly look at the flowchart of machine learning process. The first stage is the data collection, where the goal is to gather and obtain relevant and most accurate information. Next, we have pre-processing, which ensures the data is in a suitable form for a given model. And this is where our focus lies today. Pre-processing includes a variety of tasks such as data cleaning, transforming it, and most importantly for our study, feature standardization. It's here that we ensure the input data is on a consistent scale, which will directly influence how the distance-based models interpret the relationships between data points. The next is modeling, and the stage where we apply machine learning algorithms to the data to extract patterns and make predictions. And finally, the evaluation, where the model is assessed using metrics such as accuracy, precision, and recall. It's not just about how well the model fits the data in training, the training data, but also how effectively it generalizes on new unseen data. However, today, the primary focus is on the pre-processing stage and the role of feature standardization, to be exact, and to explore how it impacts the classification process. For the analysis, I used the Palmer penguins dataset. It includes measurements of 3 different penguin species, Adelie, Chinstrap, and Gentoo. It contains several features such as length of certain body parts and body mass, among others. As you can see on the graph, the data is quite unbalanced, and this aspect will also be considered in the analysis. This dataset offers a perfect test case for studying the effects of standardization because of its varied feature scales. For example, as we can see, the body mass is measured in grams. However, the bill length is measured in millimeters. The body mass has a much larger scale than the bill length. This variation in scales is where feature standardization comes into play. Here we can also see how certain features are placed based on the species, and it can be noticed that the particular species do overlap more significantly. Here, the Adelie tends to overlap with Chinstrap, in contrast to Chinstrap and Gentoo that seem to be much more easily separable. For the analysis, the data has been divided into a few subsets for exploration of how standardization and data imbalance may influence the model's performance. In the analysis, the z-score standardization has been applied. It's the process of rescaling data so that it has a mean of 0 and a standard deviation of 1. As we can see on the formula, the z is the value of standardized feature value, x is the initial feature value, u is the mean of all samples for given feature, and s is the standard deviation for all samples for given feature. Why is it important? Well, it ensures that each feature contributes equally to the model, preventing larger scaled features from dominating the analysis. For instance, distance-based methods like PCA and SVM can significantly impact how models interpret the data. Without standardization, models can misinterpret relationships between features, leading to more inaccurate results. And by standardizing features, we can make sure that differences in scales don't interfere with how models interpret distances between data points. PCA, principal component analysis, well, in short, PCA, is particularly valuable when working with high-dimensional data sets because it helps to identify patterns while reducing the computational complexity and preserving the important data characteristics. First, let's explore what kind of results we obtained for the Chinstrap and Gentoo in imbalanced dataset form. It's noticeable that the PCA performed much more effectively on the standardized data than on the unstandardized datasets. As a result, providing substantially bigger distinction between the two classes. As we can see, the unstandardized data is much more scattered around the plot. However, the standardized data is much more concise and there is a much more profound distinction between the two classes. Similarly, in the case of more overlapping pair of species, that is Adelie and Chinstrap, the results of standardization prove to provide a bigger distinction between the classes than without standardization. Next, the procedure was repeated for a balanced version of each dataset. Balancing the dataset has influenced the results by providing even clearer distinction between the classes in the case of Gentoo and Chinstrap, and the same goes for the Adelie and Chinstrap combination. Now moving on to the next step of the analysis, With the standardized data, support vector machines were applied using 4 kernels, linear, polynomial, and radial basis function, and sigmoid. These kernels were tested across all data combinations, both standardized and unstandardized, to see how it impacts classification accuracy. And the data has been divided into 2 main categories. That is standardized and unstandardized data sets. Notably better performance along all kernels. It's the upper part of the heat map. In contrast to the unstandardized data that has achieved significantly lower accuracy among all the kernels. Interestingly, the sets with more overlapping species have also obtained lower scores in all kernels. As we can see here, the lighter shades on the heat map. However, the aspect of balancing the dataset haven't influenced the results as positively, as most of the balanced datasets have obtained lower scores than the original imbalanced combination, which could be due to the loss of some more important data points and thus lowering the quality of data for classification. But now let's take a look at a more detailed metric evaluation. First, we can see the metric comparison for each kernel applied with the data and SVM algorithm for the more original imbalanced dataset. Here, the distinction between unstandardized and standardized data is relatively significant. The best results were obtained for the standardized data among all the kernels, with approximately 10 percentage points better scores. The impact of feature standardization is much more profoundly noticeable in the case of less separable classes, such as Adelie and Chinstrap, with around 30 percentage point improvement for the standardized data in metric scores. For the balanced data, the results were just a bit less favorable. However, still the standardized data implies better metric scores. And similarly, in the case of the other pair of species, the data was standardized, has achieved significantly better evaluation scores. And as we near the end of this presentation, I would like to focus on the key conclusions from the performed impact investigation. The analysis infers that feature standardization plays a significant role in enhancing the performance of distance-based models, such as principal component analysis and support vector machines. When the data is standardized, the principal component analysis captures more accurate representation of the underlying variance in the data. For example, in the Penguin dataset, standardization allowed principal component analysis to more effectively differentiate between species like Adelie and Chinstrap, which otherwise exhibited overlapping feature values. Without standardization, the dominant features, those with larger numerical ranges, obscure these distinctions. This makes standardization a crucial step in pre-processing when using principal component analysis in datasets with heterogeneous feature scales. The impact of standardization is equally profound in the support machine vector classification model. As many of you know, support vector machines are highly sensitive to the scale of input data, since they rely on distance calculations to determine the optimal decision boundary between the classes. And my results showed that support vector machine models trained on standardized datasets consistently outperformed those trained on unstandardized data across all the tested kernels, which was linear, polynomial, RBF, and sigmoid. To illustrate, on the unstandardized Penguin dataset, the SVM struggled with complex boundaries. The accuracy was significantly lower because the algorithm misinterpreted distances between the data points, leading to much more less favorable results. However, after the standardization, these models achieved a much clearer separation of the species. And this demonstrates that the standardization is not only optional, but it's actually essential for a reliable application of SVM and other distance-based algorithms. Lastly, this research underlines a broader lesson, the importance of careful data preprocessing in machine learning workflow. While it may seem like a preliminary step, standardization can have a transformative impact on the results we obtain, especially when working with models sensitive to feature scales. To sum it all up, standardization enhances the interpretability of principal component analysis, improves support vector machine accuracy and efficiency, and ensures robust results even in the face of data imbalance. So thank you very much for your attention, and I am happy to address any questions or thoughts you might have.
Thank you very much for your presentation. So are there any questions from... Okay, please.
How large was that imbalance?
The question was, how large was the imbalance?
Okay, so the imbalance was around, if I remember correctly, around 50, maybe 50 or something like that elements, but I would have to check it later for exact answer.
Do we have any other questions? So I have also one very short question. What would you say about the performance cost of the PCA analysis on large data sets? Do you think it is maybe better to create a bigger model to train it better, or would you say that using PCA and a smaller model is faster, for example, or better?
So I would say that it's true that standardization can add into the pre-processing step, and it may be large data sets. However, I would say that this cost is often outweighed by the benefits, because by standardizing the data, we not only improve the accuracy and stability of models, such as in the case of PCA and SVM, but also reduce the training time for these models by helping them converge much faster. Additionally, I would say that standardization can prevent the need for complex hyperparameter tuning, as the model's sensitivity to feature scale is minimized. So while there is an upfront cost in standardizing large data sets, it's often an investment that will pay off in terms of better model performance and reduced training time overall. So I would say that it's still better to consider the standardization.
And for your answer. So the next presentation will be interactive bicycle route planning system using an efficient Dijkstra-based algorithm by Antoni Jaszcz, Szymon Hanuks, Michał Bober, and Bartosz Bugla. So I can see. Thank you very much. So, Antoni, will you be presenting, yes?
Yes.
Okay.
Just 1 second. Is the presentation visible?
Yes, the presentation is visible. I can see you. I can hear you. So I think you can start your presentation when you are ready. And thank you. Good luck.
Okay. So, hello everyone. My name is Antoni Jasht. I'm from Silesian University of Technology, and today I'll be presenting an interactive bicycle route planning system using an original designed algorithm. The presentation will be divided into 5 parts, first being introduction, then problem, solution, results, and lastly conclusion. As a brief introduction, I will very shortly talk about some terminology connected with graph theory. The first thing is directed weighted graph, which is a graph where each edge has a weight assigned to it, as well as the direction. And during the presentation, we'll be considering such graphs. We talk about walks in the graph as a sequence of vertices and edges. And the path in a graph is a specific type of walk where each vertex is unique. And when we talk about cycles in graphs, we mean a path where the starting and ending node is exactly the same. And cycle planar subgraphs are graphs basically embedded in a certain plane. So, for example, geographical plane. And the other thing about them is that no edges cross each other. So, looking at the example on the right, we can create a cycle planar graph in such a way, so marked with red arrows. And the problem I will be tackling today is the problem of finding a cycling route with desired length and road quality. So the contributions of our research in general are designing a specific dedicated algorithm for finding such routes, as well as implementing it into practical application and general system. The data used in the experiments and the application itself comes from OpenStreetMap, which is a collaborative project created by community for community. It is open source, editable map of the basically entire world. And it contains information about cities, roads, train networks, etc. And it also consists of very useful and practical API, which can be implemented into many applications. And some of the information basically includes surface types. So each road in the OSM has a set of attributes, one of which is surface types. And on the presentation, we can see some of the examples of classes assigned to the routes. For example, fine gravel or asphalt. And in terms of the application and the considered scenario, we will be considering user preference regarding the route. So if the user wants to ride a mountain bike, they would prefer more off-road-like surfaces to ride on. While with racing bicycle, we would want to choose more leveled roads, more roads suitable for high-speed rides, basically. So the proposed solution was to create an interactive system for generating the cycling routes for the user. And to do so, we designed a Dijkstra-based algorithm which finds our route, cycling route. So with user interface, the user is able to choose a starting position from any geographical location, their preferred bike type, as well as the overall distance of the route. And the application would generate and draw the route on the map itself. So the basic principle of the algorithm can be described as divide and conquer, because the algorithm divides the task of finding the general route into finding smaller subroutes first. So in each iteration, the algorithm tries to find an optimal subroute and completes the general one bit by bit. And it does so by a specific scoring function, which is now displayed. And this scoring function basically takes under consideration currently considered node, as well as the node from the previously found subroute. And this will become much clearer very shortly. Also in the algorithm, we consider weights of the edges, not only in the matter of length of the road itself, but also the surface type. And this acts as a multiplier. The surface type acts as a multiplier. So basically, if we have less favorable surface type, the road is basically counted as double length, while with more favorable ones, the length becomes shorter. So for example, with 1.5 multiplier, we would have 1.5 longer route considered. And to give you a better insight into the workings of the algorithm, here is a short example. So starting from the red dot, the starting position, we consider some of the nodes within the smaller range. And we run cut-off Dijkstra algorithm to find all of the possible routes, all of the possible nodes, which we can write to directly in this subroute. When we find one, we try to go to it using a star algorithm with the heuristic based on the length and the distance to the chosen node, as well as the surface type and the weight. Upon finding the subroute, we began to iterate and try to find another one, this time considering the previously found subroute. So the newly found subroute will be quite close to the rim of the circle of the previously found subroute. And we do this a couple of times. And after each time, the algorithm checks if the already found general route, if it's too long or if it falls within the error range of the estimated total length. If it happens to be too long, we backtrack the algorithm and try to find a smaller subroute. And as the end result, we have a complete route, which is basically a completed cycle in a graph. We tested the algorithm in terms of the number of divisions, number of subroutes, and we found out that the number equal to 5 generally results in best looking routes. because with, for example, n equal to 3 or basically n equal to less than 5, the ending result was triangular or rectangular, really not an interesting route for cycling. While with n greater than 5, it tended to interlace with each other every subroute, so it ended up quite messy. And we also tested the impact of bicycle type, and as you can see in the presented example, the setting was the same for the routes, so 9 kilometers of total length, as well as the same starting position, but the type of bicycle was different, and the found route was also different in terms of the quality of the roads and surrounding area. So with mountain bikes, we had more green areas, more rough roads to traverse through, while on the right, we had more urbanized area. And we also performed some numerical evaluation regarding the total length of the found routes. We tested it on the short routes as well as the longer ones. And in both cases, the acceptable mean average percentage error was within the acceptable range, so below 5%. And we also tested the delivery speed of the application and the interactiveness of the system using the following metrics. And the results are as follows. We can see that the main delay comes from painting the map and trying to draw the route bit by bit, which is something we could try to address, but it's unomittable basically in terms of painting the route on the page. So limitations of the research and the used algorithm is insufficient or incorrect edge labeling, which unfortunately we cannot address, or rather it is very hard to address because the OSM maps are created by community and sometimes error might happen. We also have an extensive amount of possible surface classes, which are hard to all take account for. With the problems connected with the algorithm itself can be listed as finding routes in a more secluded area, which are very sparse in terms of nodes and graphs, and can be difficult for the algorithm to basically find any subroutes. And the difficulty itself comes also from assessing the predictions, which, as was presented, is mainly visual, unfortunately, because it heavily relies on the user's experience. So in conclusion, we developed an algorithm which performs well for the considered tasks and generates routes with acceptable total distance. It also adapts to different surface types and user preference, and can be easily adjusted to find routes with more desirable features. And we also plan to develop the system and the algorithm itself further to give the user more freedom of choice and flexibility. And I think that's all. Thank you for your attention.
Thank you very much for your presentation. So, are there any questions from the room? Yes?
Yeah, thanks for the presentation. As a keen cycler, I not always want to have the same route as a suggestion. So although the lengths might be the same from one day to the other day, I want to have some diverse routes. Did you also include some randomness in your algorithm? Because Lecturer would decide to always find the same route if there are not two routes having exactly the same local weights and distances.
Yes, thank you very much for the question. It was considered by us if we wanted to the algorithm to be deterministic. So, as you said, produce the same route every time or include some randomness. And we decided to include the randomness in the choice of subroutes. So before I presented the scoring system where the algorithm in the subroute parts chooses a specific node to go to, you can modify the algorithm to, for example, choose top 10 scoring nodes and then choose one randomly. So we included, in this part, we included randomness to basically choose from the top 10 nodes. And what it does is, if the algorithm sometimes produces a very bad route, a user can generate another one, and each time it has a chance to generate more interesting one than just simply being stuck with the one determined.
There are questions? Yes?
I want to ask, how do you get the road type? Is it on the OpenStreetMaps metadata or to determine it somehow? The type of the road.
The type of the road. So basically, from the API, we can get a list of edges, and with these edges, each edge acts like an object which has some attributes. One of which is a list of attributes assigned to this edge. One of which is length, and one of which is road type, and one of which is surface type. Road type as a highway or local road. So it is basically a string which we can extract from the edge and then consider in the algorithm itself.
Thank you very much. And the third presentation will be Fantastic Fishes and How to Classify Them by Piotr Żerdziński. Piotr, are you hearing us? Are you connected? Hello, I can see you.
Hello, hi.
And I can hear you.
That's great.
Great. So when you will be ready, you can start.
Okay, so good morning. My name is Piotr Żerdziński, and I am a student of Silesian University of Technology. I'm very pleased to present my work today. I have prepared for the conference. The title is Fantastic Fishes and How to Classify Them. Today's presentation will be divided according to the following agenda. Introduction to the problem, where I will discuss the key concept related to this product. I will then move to the proposed architecture, which includes the image preprocessing techniques and the convolution neural network module. And the next section will focus on research methodology and details of the experimental setup. In the research section, I will present the outcomes achieved by the proposed architecture and compare with results from the other published works. Finally, I will summarize what was accomplished and share the key conclusions. So, among all vertebrates on Earth, fish exhibit the greatest biodiversity with more than 30,000 species and more being discovered each year. It is therefore necessary to monitor biodiversity to maintain healthy ecosystems. However, manually examining hundreds of hours of recordings by specialists is too costly and time-consuming. In this context, automated image classification systems become invaluable as they allow continuous classification at the fraction of cost and time required by the traditional methods. So the main motivation behind this work was to develop a system capable of effective classification while maintaining the minimal computational complexity, making it feasible to the practical application. Image classification is one of the fundamental tasks in artificial intelligence, and it covers a broad range of challenges. Typically, this involves distinguishing between dozens or even hundreds of classes that are often very different from one another. However, in this case, we are dealing with more specialized category known as fine-grained visual classification. Here, the images being analyzed belong to a single larger metaclass. For example, this could involve identifying car brands, but more commonly, the fine-grained visual classification is used to classify species within the higher taxonomic level, such as different breeds of dogs or species of fish. Of course, this distinction isn't always strict. When classifying aquatic species, for instance, a dolphin, which is a mammal, or shrimp, which doesn't even belong to the same phylum, could be still part of the classification task. Therefore, the fine-grained visual classification is a more demanding problem due to need to distinguish often the small differences between the analyzed classes. Thus, sticking to the presentation case, to distinguish between two fish species, it is necessary to rely on features such as fin shape or differences in coloration. The challenge of fine-grained visual classification goes further than identifying the subtle differences between species. When working with underwater images, we also face additional issues related to the image quality, such as noise, discoloration, distortion. Water, along with the particles suspended in it, like pollution, plankton, etc., absorb, scatter, and reflect sunlight. The extreme wavelengths of visible light are especially absorbed, resulting in underwater images being dominated by green and blue colors. This significantly reduces the visibility of any difference in fish coloration. So, to address that issue of poor image quality, a simple preprocessing step was applied to only this data set containing underwater photos. The pre-processing involves brightening the images by increasing the value of each pixel by 50%. For very blurry images, the brightening helps distinguish the fish from the background more clearly, while for the clearer images, it makes the fish features stand out more. Okay, yeah. As I mentioned in the introduction, fine-grained visual classification requires overcoming the challenge of capturing subtle difference that distinguish one class from another. To tackle this, I proposed attention-based CNN model. Attention mechanisms, which are widely used in similar tasks, enable the model to focus on the most relevant parts of the images, ignoring areas that do not provide valuable information. So in our case, this allows the model to prioritize features of the fish while ignoring the background. Additionally, skip connections were incorporated into the network, which helps preserve the low-level features while combining them with the high-level abstractions. This leads to more detailed and informative representation, improving the model's overall performance. So in this work, as you could see, I employed the attention mechanism based on the CBAM, the convolutional block attention model. The core function and effects are similar to those introduction in the Attention is All You Need paper, but CBAM enhanced the features maps produced by CNNs by applying both channel and special attention mechanism. And the key point is that CBAM is designed to be lightweight, making it suitable for efficient implementation. As I mentioned earlier, a simpler preprocessing step was applied to the datasets with underwater images, which slightly improve both the results and stability of the training process. For datasets containing images taken outside the water, no specific preprocessing techniques were used. Given the relatively small size of many of the analyzed datasets, basic data augmentation techniques were applied. So it was vertical and horizontal flips with the 90% probability. Each image was scaled to 64 by 64 pixels. It helps to reducing complexity. Regarding the settings and hyperparameters, each dataset was split 80% for training and 20% for testing. Despite the imbalance in class counts in some of the tested datasets, no adjustments were made to address this. And this decision was made to simulate the real-world condition where certain species naturally occur less frequently, and the model needs to handle this such case effectively. So you can see that 7 datasets with different characteristics were used in these experiments. Some of these datasets exhibit significant class imbalance and with only a few images available for certain classes. Among the analyzed datasets are those with the large number of images and fewer classes, which helps the model learn accurate patterns. However, the QET dataset stands out, containing an average of only 8 images per class across more than 400 classes, making it particularly challenging. One of the key benchmarks for fine-grained visual classification problems is the Fish for Knowledge dataset. It presents a wide range of challenges, include class imbalance, varying image quality due to challenge in the water clarity, lighting condition, and so on and so on. So on this slide, you can see the results achieved by the architecture I proposed compared to the reported in other works. At a glance, the best results were obtained for 4 out of the 7 analyzed dataset: the Croatian fish dataset, the deep fish dataset, large-scale fish dataset, and fishback. Though the fishback, I couldn't find any properly conducted test for direct comparison. For the next 2 datasets, the Fish for Knowledge and Fishgrass, the results were quite close to the highest reported scores, and the worst performance, as you can see, was the QET dataset. And however, for the Fish for Knowledge dataset, the best published result is 90.77%, achieved using pre-trained ResNet 50, a model which is over 80 times larger in terms of parameters compared to the one I used. And similar is the Fishgrass dataset. The highest recorded accuracy is 90.21, which was the 3rd highest result. The best score was the 100, achieved by the authors using a pre-trained ResNet, also followed by the authors with EfficientNet. And both of the models are significantly more complex and utilize weights from pre-training on the image dataset. And similar situation is observed with the most complex QET dataset. The best performance here was achieved by the BCNN architecture, which is, I believe, based on the two VGG16 models. And the solution is also pre-trained on ImageNet and has at least 20 or even more 20 times the complexity of the model proposed in this study. On this slide, you can also see the detailed results for other key metrics such as recall, precision, and F1 score, only for my architecture. And here you can see the graphs provided for underwater dataset accuracy and out of the water datasets. Here is the graph for the QUT datasets with because of the complexity, it includes top 3, top 5, and top 10 accuracy metrics. So, moving to the conclusions, in this study, I aim to enhance the classification of fish species using a specialized convolutional neural network designed for the fine-grained visual classification. This task involves distinguish between similar species in the same environment, in the particularly challenging with underwater images, which often suffer, as I said, from the poor quality, noise, and color distortion due to lighting conditions. To tackle this issue, I applied simple processing techniques to improve the quality of the underwater images. My model was based on the convolutional block attention model, allowing it to focus on critical features while remaining lightweight. I didn't say that previously, but the model is only 1.4 million parameters. Talking about the issues with that architecture is that not directly within the model itself, but rather with the preprocessing stage. As you could see, the fluctuation on the test sets, they're because of the class imbalance of the data sets. As I mentioned earlier, this imbalance was not specifically addressed, while some species are less numerous, reflecting the real-world situation and allowing us to access how models perform under the real condition. It remains the fundamental issue that should be resolved. Talking about the future works, it would be beneficial to focus on developing universal image preprocessing techniques that can effectively address the main challenges associated with underwater images. One possible direction of this work would be to use generative models, and also working on the project that could help preserve the true colors of the fish. So thank you for your attention. If there is any question, I would love to answer that.
Thank you very much for your brilliant presentation. Now we can ask if there are some questions from the room. I don't see any for now, so I will ask a few questions, maybe one question longer. Have you made some comparisons between using your model without and with the attention layer? What I mean is, how much of an effect does it make in this special scenario?
I just said that, and I decided to use the attention because of the effect wasn't large, but it was like I don't want to lie to you, but maybe like a couple of percent, like 2 or 3, something like that.
Okay, thank you. And have you considered using, or did you use some noise reduction in those underwater images? Because you've mentioned that there was a lot of noise and other floating particles. So
I thought about that, but the main motivation was to make architecture that would be ready to use in every case, every scenario, and something like that. So yeah, it would be, as I said, it would be beneficial for the model at overall, but I didn't use that.
Thank you very much. Are there maybe any questions now? Okay, then thank you very much.
Thank you.
And the fourth and the last presentation will be the research setup for measuring and recording the impact of power supply method of energy losses in a BLDC motor by Andrzej Sikora, Rafał Brociek and Adam Zielonka. And this time it will be made here.
Good morning, everyone. First of all, I would like to say I'm very happy to be here, to return here after a few years break before the pandemic. I also was at this conference. I like this place. I like the Lithuania. So, my name is Rafał Brociek. I am a researcher at the Silesian University of Technology. Andrzej Sikora and Adam Zielonka are my scientific friends. To be honest, they are the main authors of the research, of the presentation. My presentation is more electrical than the software. The title is The Research Setup for Measuring and Recording the Impact of Power Supply Method on Energy Losses in a BLDC Motor. If it's not problem, can I sit? And for me, it's be convenient. So, the outline presentation is as follows. First, I say about the technical description of the test stand, which was the main goal of the research. Next, I say something about the sequences of supplying voltages to the winding of BLDC motor, followed by a schematic diagram of the research setup. Next, I go to the temperature measurement and recording system, and also present the result of heat losses, energy losses, and finally I will go to the conclusion. So here on the figure we can see the test stand, which was the main goal of the research. The subject of our research is SMZT permanent magnet motor with a rated power of 1 kilowatt. The motor is powered with a rated voltage of 48 volts. It is connected to a load machine driven by a permanent magnets of similar rated power through two couplings and a Dataflex torque meter. As you can see, the test stand is presented on the figure. So, we consider 6 different sequences of supplying voltage to the windings, and here in the table we can see the 6 options. Next, I would like to show you the schematic diagram of the research setup. Let's start from the left upper corner. Here is a power source. Next, we have a DC-DC converter. Then we have electronic commutator bridge. here was the main subject, the tested BLDC motor with a Hall sensors. Next we have a torque meter, load machine, diode rectifier, and another DC-DC converter. In the center of the diagram, it was electronic control, load regulation, and data logging systems here in the center. How we collect the data from the sensors for transmitting measurements data to the database, and standard ASP8266 module was used. This module received measurements data from the Attini microcontroller using RS232 transmission, and then utilizing Wi-Fi connection sends the measurements to the database. Here on the diagram we have resistors R2 and R3, and these resistors are used to configure the pins of the ESP module. The resistance characteristic of the used thermistor is presented on the figure. This line is described by the equation 1 when RF reference resistance and A, B, C, D are the constants, and it was taken from the specification sheet of the producer of the thermistor. Our goal, our research, we want to measure the temperature using the thermistor, as we see at the equation 1, from which we can determine the temperature depending on the resistance of the thermistor. For this purpose, we use the equation Steinhardt, which is equation 2, where parameters are also taken from the datasheet specification. A1, B1, C1, and D1 are the constants. Determining the temperature, besides equation 2, requires taking into account voltage drop across the series connected resistors, limiting the current according to the, of course, Ohm law. The experiment we carried out for 6 different operating conditions of the motor with specified low torque, and it was 1/3, 1/2, and 2/3 of the nominated of the rated value, as well as specified shaft speed values of 1/3 and 2/3 of the rated normal speed value. What we get the result. Here on the slide we have the case of 1/3 load value, and for 2 specified shaft rotation speeds. On the left we have 1/3 of the nominated of the rated speed rotation, and on the right figure we have the case of 2/3. We can see the temperature is the mark by red line, and the resistance is marked on the brown line. Also dashed line is marked the ambient temperature. We taking into account the time interval from 0 to 600 minutes. Next 2 slides is very similar to the previous one, but it concerns the another case of the torque. Before was 1/3, now is 1/2. the results are similar. Of course, there are differences, but the characteristics are very similar. Here we have the case of 2/3 low torque case. Okay, so comparison of temperature increases, in other words, energy losses during steady motor operation. So green line represents plots for 1/3 case, purple line is 1/2 case, and orange line is 2/3 case. While the plots drawn with a solid line denote the case for the shaft rotation speed equal to 1/3 nominated rotation speed, and plots drawn with a dashed line denote 2/3 nominated rotation speed. And let's go to the conclusion. So the research setup implemented within the described studies met the expectation which we have. Heating of the motor components is directly related to the efficiency of converting electrical energy into mechanical energy. Both electrical energy losses resulting from current flow in the motor windings and also losses stemming from losses in the magnetic circuit affect the overall drive efficiency. The research clearly demonstrated that with an increase in the motor load, energy losses released in the form of heat increase, as this is due to the higher current flow through the motor windings. Furthermore, with an increase in rotational speed under a given load, energy losses also, of course, increase. This is attributed to providing a higher average voltage to the motor windings and supplying the motor windings with voltage at a higher frequency. So, thank you very much. I hope it was not boring. I know it's not about the software. In general, computer science, and it's rather electrical presentation, but I hope it's not boring for you. And I'm happy to be here after a year's break. Thank you very much.
Thank you very much for your presentation. So the question is, of course, are there any questions from the room? Yes.
Thank you for the presentation. It's not very related, but you collected a lot of data and analyzed them. But my question is related to the reason of this research. It's come from the industry to check, or you just?
Yes, we want to. First of all, we want to build a test stand. This is the first reason, and second reason, we want to measure the loss of energy. What is the temperature when we use different values of the rotation speed? So this is the main goal. So we build the test stand and we measure the data, collect the data to database and check the heat losses accordingly.
You will use this technique to check
in the future. My professor, who is the leader of the team, try to use it in the industry. So,
thank you. Does anyone also have a question? Okay, so as I don't see any other questions, thank you again very much for your presentations and answers. Here I give you your certificates of delivering the presentation. Thank you again very much. And
thank you also. Thank you very much.
And dear colleagues, thank you very much. The session is closed, and I would like to present the certificate for the chair of the section, Professor Mikhail Pechar.
Thank you.
Okay, thank you very much. And now we'll have a lunch break. And after lunch break, the second part of this section will be continued right here in the same room. Thank you. And the lunch. we will start the second part of the special session on intelligent system and software engineering advances. And this section will be chaired by Professor Zbigniew Marszalek.
Good morning. I would like to welcome everybody on today's session. The first presentation is assessing the performance on NFV and GMM in the soft classification of kidney stones in heights from vital data. Is the author here of this presentation? Welcome. I think you can, or you want to speak to, how do you want?
Just like that.
Okay, sit now.
Hello everyone, I'm Osha Shobonena and I will be presenting research on identification of kidney stones composition. This was a joint research by ICIST, myself, and Arunas Želvys. It's a collaboration between Vilnius University Faculty of Mathematics and Informatics and Faculty of Medicine, of course, and also Vilnius University Hospital Santaros Clinics. So, first of all, introduction to kidney stone classification. So, why it is important? I'm sure most of you, all of you, know about kidney stones, but probably what could be surprising is that they can be of various different types, and they can be composed of different materials, different components, and in different proportions. This results in different treatments and preventative strategies for patients. So, for example, there are stones made from calcium oxalate. In different variations, they are the most prevalent types of kidney stones, and the management for preventative care includes dietary changes and increase in fluid intake. While other stones, for example, struvite stones, they are a result of kidney infection, and they require antibiotics and surgical removal of the stone. Other stones require, for example, uric acid stones require again dietary restrictions and some medication as well to change the alkalinization of urine. Yeah. So these different types of kidney stones influence different treatment and preventative strategies, and there are still some challenges left in identification of the different components. So first of all, there is very high variability. So kidney stones can be composed, as mentioned, of different materials and also in different proportions of those materials, and this will influence different treatment and preventative strategies. Also, there are limitations in imaging methods. So, for example, traditional imaging methods such as CT or X-ray often tend to miss especially small kidney stones. So, for example, if you take a CT image, it has dimensions usually of 512 by 512 pixels, and a small kidney stone might take up of 1 or 2 pixels, and you can't really tell the composition based on that alone. So that's another challenge. And also the challenge is manual analysis of data. So for example, before FTIR data that I'm going to present, there was a method to identify kidney stones, which is called wet chemistry, where lab technician would take a sample of kidney stone, grind it up, and apply some different chemicals, and then measure changes in either color or temperature or combination of other materials that appear in the solution. So that was time-consuming. And also nowadays doctors use other methods, but also it's based on manual analysis. So for example, with FTIR data, the technicians, what they do now, they take a huge file of different spectra of kidney stone data, and then they try to manually compare that spectra to patients' kidney stone spectrum and see, well, what's different, what's not, and which component, and especially what percentages of that component might be there. So it's very, well, as you can guess, it's not that accurate and very time consuming. So we start from FTIR data, which is a result of Fourier transform infrared spectroscopy. So this is an analytical technique where the absorption of infrared light is used to identify and characterize chemical components of the kidney stone in this case. So a specimen of kidney stone is placed in the spectrometer, and infrared light then is applied to the specimen, and then the spectrometer measures how much light is reflected off the sample, and different molecular bonds absorb or reflect light at different specific wavelengths, and this allows for identification of different components. So then we use non-negative matrix factorization, NMF. This method decomposes one matrix, V. In our case, this would be the observed spectra of kidney stone data, into two matrices, W and H. So W would represent the base spectra, those fundamental components that kidney stone might be composed of, and H represents the abundance or the concentration of those different components. And from here we can identify that, for example, this kidney stone is composed of 80% calcium oxalate hydrate, and then, I don't know, 20% of albumin or something. After that, we used Gaussian mixture model. This is a probabilistic model for soft classification. Now, soft classification is a bit different from usual classification. So in usual classification, you can identify, well, you can assign one class for each data point, and in soft classification, multiple classes are allowed to be assigned at once. So the model, Gaussian mixture model, is defined by this expression that you can see here, and it represents the probability of observing a data point within the mixture model. So for the data, we used an internal, well, we compiled an internal data set from Vilnius University Hospital Santaros Clinics. We had data of 91 patients' kidney stones. 77 of them were single component and 14 were mixed. And those 91 kidney stones were composed of seven fundamental components. Here you can see 5 of them, because this table lists the frequencies of kidney stones, of single component kidney stones, and others were in mixed component kidney stones, like small amounts, 10, 5, 10, 20%. So this is how the data looks like. So it's just a collection of around 4,000 data points, and basically it can be represented as a graph. So these are graphs of those fundamental components, and then we have a similar line of patients' kidney stone spectra, and then we try to compare which basically which lines are closest to the patient's spectra, and also what percentages of those components might be there. So we propose a method for classification of kidney stones. First of all, we need to do some additional processing of data. So because the spectrometers might be different, and they might use different reporting standards, we need to align the spectra by using linear interpolation. So we take the if you imagine here, we take x-axis of base spectra, and then, for example, patient kidney stone spectra might have a reading at 4,021.8, and then base spectra has a reading at 4,022.3. So we align patient spectra to those base spectrum. Then we decompose each spectrum into 100 non-negative components using non-negative matrix factorization, and then using that we apply GMM mixture model to basically have the model for predictions, and then we predict the composition using those 100 features. To evaluate the model, we use concordance metric. This is a bit different from usual, for example, F1 score that's used in classification quite commonly. So in F1, you only care about the identification of correct class, and here we care also about the percentages. So for example, a correct prediction would be all components should be identified correctly. So if it's one component, then only one component should be identified, and if multiple components, then those multiple components should be identified exactly like they are. And the compositional variance is allowed of up to 20%. So for example, if the true composition would be first element 80% and then second element 20, then 90 and 10 prediction would be correct, but 61 and 39 wouldn't be. So the results. First of all, we started from Euclidean distance predictor. It's the first line. So we just basically compare Euclidean distances between patient lines and component lines. This didn't result in much, as you can see. Then we tried applying non-negative matrix factorization only, so to have those base spectra fixed, and then try to come up with composition percentages. And then we tried to improve it, playing on this with this non-negative matrix factorization results. So then we used NMF as, well, basically as equivalent for PCA in dimensionality reduction, and then we applied a Gaussian mixture model. As you can see, concordance percentage, the one that cares about not only about the identification of components but also about identification of percentages, it remained the same, but F1 score increased quite a lot. So this means that the proposed model, although has identifies the same amount of correct amount of kidney stones based on composition, it has a possibility to even increase that score, because it starts identifying more and more correct components, even though their proportions are off. Then we tried comparing this our proposed model with our proposed method with different other methods, combining non-negative matrix factorization for dimensionality reduction and usual machine learning techniques. And as you can see, none of them quite improve the concordance percentage. So these are results graphically. In the top part, in A and B images, you can see correct predictions. So those gray lines in the background are base components that kidney stone might be composed of. Blue line is correct prediction, and black line is patient's kidney stone spectrum. So here, top part is quite, well, it might look quite easy, but if you look at the bottom where incorrect predictions are illustrated, you can see that, for example, here, here there's a misidentified calcium oxalated hydrate stone. So red one is incorrect prediction, yellow one is true prediction. As you can see here in this part of the graph, the incorrect prediction seems to line up much more better than true spectrum. But if you see here, the peaks of true spectrum are more prominent than the incorrect prediction. And also here, in both parts, it seems that wrong prediction seems to be more suitable, and we even discussed this with urologists, and they identified cases like this where cases like this as potential for mislabeling even. So for conclusions, There are several. So first of all, non-negative matrix factorization improved the composition of kidney stone spectra compared to other methods compared here. Also, there is a limitation of F1 score, which is usual for classification identified, where F1 score doesn't fully capture the aspects that are of clinical importance. And also the importance of data quality became very apparent because, well, the manual labeling is very, very difficult and time-consuming, and sometimes errors might appear, even especially for multi-component kidney stones. So this needs to be improved in future research. And I think that's it. Thank you for your attention, and I'll answer some questions if you have.
Thank you. If anyone would like to ask a question, please ask a question.
My question is, are those kidney stones need to be extracted before the decomposition, or is it some non-invasive way? And if so, then what is the usage of such technique?
Yeah, so kidney stone needs to be placed in the spectrometer. So it needs to be extracted from the patient beforehand. Usually it's not done by surgical removal. It's like left for biological processes. But the main advantage of this technique is that the sample remains not untouched, but it's not affected by this technique. For example, if you compare to previously used wet chemistry technique, where you have to like physically destroy the sample, so it's better in that way.
Okay, thank you very much.
Thank you. If anyone want to ask a question, please.
I have a question, theoretical one, about practical application of non-negative matrix factorization. So you said in the conclusions that increasing data set is the future work. So what will you do when your data set increases so that the matrices you get are so large that NMF just stacks or something? What about computational side of this? Thank you.
Thank you for the question. Yes, we are planning to increase data size, but not as much up to the point where it would become a problem. It would become a problem because first of all we need to increase the quality and representation of different kidney stones spectra. So for example, we had only I think 14 or something multi-component kidney stones, and we would need to even with the same amount of components, we might have different variations. So we might play on that.
Is it okay?
Yeah, so if it's not too large, it's okay. I mean, yeah. Okay.
I mean, if we had more data, like I don't know, thousands of
yeah, of course, in the big data era, I know that those medical data sets are funny.
Here's another question, please. Sorry, a moment. Please.
Do you also have the chance? Yeah, thanks. Do you also have the chance to get some external data, maybe blood pressure of the patients or at least the age of the patients, because that also could help to correctly classify? I know that it's quite a good setting that in the lab you only have the sample of the kidney stone, but it might help to improve the accuracy even further.
Yes. So in theory we might be able to get the data, but it wasn't done for this study because it was just exploratory study for using this spectrometer data.
Okay. Thank you. Is another question, please?
Hello, thank you for presentation, of course. And by the way, is there a possibility that different types of kidney stones do compose one bit, let's say one stone? Is it possible? And for example, since I'm not familiar with this subject much, can you also clarify whether the size of the kidney stone can affect that spectrogram or the shape of it? Somehow you can, if you will place in the spectrometer differently that stone, will it produce different results? Can you experiment with that? in order to avoid errors unnecessary, of course.
First question was about different components in kidney stone. Yeah, so that can happen, and nowadays we had I think around 14 or something multi-component kidney stones. So those were kidney stones that were composed of, for example, calcium oxyhydrate and albumin, a mixture of two components. And for the second one, I have to admit I'm not a physicist. I don't use spectrometer, so I don't know, to be honest, how the shape might affect the results of spectrometry. But I trust the technicians that they did good job while collecting the data.
Yes, it's correct.
Yeah. So. I have a question related to the data set. So as you say, one of the main issues is to annotate the data. But do you have not annotated data to use, for example?
In the hospital, you mean?
The one in general, or if there is any similar data set out there from some other country which they provide the data but not the annotations.
Yeah.
Do you know if you have
I'm thinking. Yeah. So this type of data is collected for patients during the treatment or diagnosis. So in theory, all this data will be labeled, because if you don't label the data, you don't know what kind of kidney stone it is, and you can't assign treatment. But as it's true in all the medical research, sharing the data might be very complicated, and even assigning labels might might create some ethical dilemmas in some hospital where they decide not to provide data based on that. So it might be the case that some hospital would agree to share unlabeled data.
I was mainly asking because nowadays we are working with zero-shot learning, few-shot learning approaches, and as one of the colleagues said, those approaches are also in terms of saving computational power, and also when you don't have enough data about the specific type of context. No, so that will be very interesting to know if you can use also this type of techniques, zero-shot learning, few-shot learning, or neuro-symbolic learning, to try to see if you can have better results without a bigger amount of data, as you said earlier. Yeah, but I think zero-shot learning and few-shot learning will be much more performant than
one use case of that would be to verify the labeling. So we can just choose to disregard the labeling and then see how labeling
yeah. That was one of the secondary objectives of those type of techniques. So yeah, that was it. And if I have still time, at the end you said that the F1 score was not a very good metric, but do you have any idea on what you are going to use in the future to
that I presented here, because F1 score would be the same if kidney stone was composed of two components, one of 90% and 10%, and then the other way around. It would be the same. But our metric takes into account the percentage as well, so they have to be correct also. So we are using that.
Okay. Thank you.
No, thank you for your
Thank you.
presentation. The next presentation is on the Zoom. GAN generative adversarial networks enhances with CLAN for image generation process. Tomasz Bury. Hello, do you hear me? Yes or not? I don't hear you. I hear you.
Good afternoon, everyone. My name is Tomasz Bury, and I'm a student at generative adversarial networks that is enhanced with Clay algorithm. So I'll present it to you. So firstly, I want to briefly introduce the article motivation, then present the objectives of this project, shortly present the concepts of generative adversarial networks. Next, I will present the modified architecture, present the dataset that was used to work on this project, and the results that were obtained. Firstly, despite a very large volume of data generated globally nowadays, over 2.5 quintillion bytes, there's a scarcity of diverse, high-quality medical data sets in critical fields. So in real-world scenarios, there is often an imbalance between the normal cases and the shortage of the cases that present, for example, a disease. So this imbalance can significantly impact the performance of traditional machine learning models, notably when the domain, when the model operates in domain that accurate diagnosis is crucial. And to address this challenge, GANs, for short, it's generative adversarial networks, are employed to generate synthetic medical images, such as X-rays. These synthetic images play a crucial role in enhancing diagnostic tools, especially in situations where real data is limited. However, generating high quality and realistic X-rays or images remains still a complex task because of a lot of features that are presented on the image. So in this project, Clay algorithm was used to adjust the image contrast, making those subtle features more visible, which is especially advantageous for detecting abnormalities like pneumonia, where distinguishing between healthy lung and the affected one can be very challenging. And by combining GANs, the network produces more realistic and accurate X-ray images. And this approach not only helps increase the size and diversity of the dataset through data augmentation, but also improves the performance of diagnostic models, which we will see at the end, making them more reliable and accurate when it comes to detecting pneumonia. The medical field benefits significantly from these advancements. Improved image quality enables earlier diagnosis and treatment, allowing doctors to identify subtle abnormalities sooner. This leads to reduced strain on healthcare systems by facilitating quicker and more accurate diagnosis, which can help prevent the need for more intensive treatment later. And machine learning models also enhance the efficiency of medical resource allocation, enabling healthcare providers to prioritize high-risk patients and minimize unnecessary tests to make sure that the triage is used. They also support decision making by offering clear, visible data when it comes to support when diagnosing. GANs were introduced by NFIO in 2014. GAN is a neural network that consists of two separate neural networks, the generator and the discriminator. The generator part creates synthetic data, for example, images from a noise or random input, while the discriminator distinguishes between real data and generated data. Both networks are trained simultaneously in a competitive process where the generator tries to create such a fake image that discriminator couldn't really tell if it's real or fake. And the discriminator becomes more accurate at detecting it. And the adversarial training improves both networks over time, with the generator producing more realistic data. And GNNs are used in applications such as image generation, video synthesis, data augmentation, which was the topic of this project. The loss function used in GANs in general is defined as follows: minimize over G, maximize over D, VOD and G equals the expectations with respect to X sampled from P data of X of log D of X, plus the expectation with respect to Z sampled from P data of Z of log 1 minus D of G of Z, In this context, G of Z is the generator and the D of X is the discriminator. The discriminator tries to maximize function V of D and G, while the generator minimizes the function, which leads to minimax relationship. In context of medical imaging, the contrast limited adaptive histogram quantization, which is CLAY, it's used to enhance the contrast of X-ray images of lungs. It works by dividing image into small regions and applying histogram equalization to each region, improving local contrast without amplifying noise in uniform areas. And this enhancement makes subtle features such as those that are indicating a disease like pneumonia more visible. And by improving the visibility of key details, CLAY algorithm helps neural network to better classify accurately if the lung was having some issues or it's healthy one. And in this project, it also helps GANs to generate more realistic and accurate images of the lungs. The model was trained and tested using the lung X-ray dataset from Germany, and it consists of 3,000 chest X-rays. So in this architecture, we use the data that was created in the dataset, and we pre-process all the 3,000 images by CLAY algorithm, and we use two-part architecture. In the first part, we classify the lungs before generating some artificial cases, and for the second part, we generate the missing data to balance the data set with the proposed architecture, and then we classify the data set that contains the artificial cases, and we compare the results. As I said before, the data set has 5,863 chest X-rays, and there are 1,341 healthy and 875 pneumonia cases. So we can see the imbalance. And the images were resized from 2,090 pixels to 1,858 to 224 times 224 pixels during the pre-processing, when it was also adjusted by CLAY algorithm. And the generated images of lungs were mostly very realistic and closely matched the real X-ray images, while it had some few minor issues like being overexposed or having small artifacts, which is completely normal when using GANs. And most of them were good enough to further analysis. And interestingly, adding these synthetic images improved the classification accuracy by 0.55%, boosting the model's performance from 93.06% to 93.61% that is presented here. The confusion matrix shows that the model performs fairly well in classifying X-ray images. Out of the total predictions, 197 healthy lungs were correctly classified as healthy, and 386 pneumonia cases were correctly identified. However, there were 37 healthy lungs misclassified as pneumonia, and 4 pneumonia cases misclassified as healthy. Overall, I think that the model demonstrates fairly high accuracy with only a few misclassifications and true negative cases. However, there's still room for improvement. I think that it's important to note that generated images should not be used directly for diagnosis, especially when there is a class imbalance. And Using deep learning in medical imaging raises some ethical and security concerns. So protecting patient data and preventing adversarial attacks on GANs is essential. And future research should focus on creating secure, realistic image generating pipelines tools with minimal data possible, and which will address all the concerns that I said before. Thank you for your attention.
Question for Tomasz? No, thank you very much for your presentation once again. Goodbye. It's a moment I give certificate. I'm sorry I made a mistake because I should give a certificate. Should I ask again? Thank you very much. Nice presentation.
Now we will switch these two.
Excuse me, we lost our presenter, so maybe we will ask for. Yes, we lost him online somewhere. We lost him.
So the change now. Alicia and Agnieszka, please come here. The impact of different generators to deep convolutional models on the quality of generated photos. The topic of the presentation.
Okay, so I'm Alicja Polowczyk, and today's presentation will be on the impact of the generator constructions in the generative adversarial networks, especially for the deep convolutional GAN type on the quality of the generated photos. Okay, so our presentation focuses 5 key and main parts. As always, first we'll talk some background informations, and then we'll present the main idea of the GAN algorithm and feature coding in the latent space. And later we will move on to our problem and its solutions, supported by the obtained results of our research. So, during generating images, the GAN architecture plays a great role. In its constructions has 2 components, the generator and discriminator. The advantage of the GAN models that use convolutional and convolutional layers is adversarial learning, and the discriminator classifies which photo is real and which is from the generator. Thanks to this component, we have an adversarial loss function, and our generator produces better and better pictures in the training process. And this GAN architecture is shown in the figure, where we give 100-dimensional vector to the generator, and then this vector is processed by the generator also. Later, real photo and generated photo are sent to the discriminator, and the discriminator decides which one is really real. Later, we get the loss for the generator and discriminator, and these components train. The input vectors come from the multidimensional space, which is called the latent space. This space contains features of photos from the training dataset. For example, hair color, skin color, or additionally placement of mouth, nose, and eyes. And each vector is unique. And after transforming by the generator, represents a unique photo. Also, these vectors come from the normal distribution. So our goal is to construct such a generator in the Distingan model, which will create new face images that will contain features from real images. For example, skin color, hair color, or general face shape. Our aim is for the generated images not to be blurry and not to look like noises, like random arrangement of pixels in the images. So our goal is to find the good structure of the generator that can do it. And by an efficient generator architecture, the basic Distingan models can aid the data augmentation process, where the new generated images can increase the diversity of the training dataset. For example, in the classification problems or even in problems where the dataset is limited. For example, in the medicine, where it is sometimes difficult to collect a lot of image data. And an image dataset used in our research contained 10,000 high-resolution images. It included diverse photos of faces of men, women, and children. And additionally, frequent features were glasses and smile on the faces. So the structure of our discriminator is shown in the figure. And this component mainly consisted of the convolutional layers. It didn't contain the max pooling layers. So to reduce the image, a larger filter step was used. Subsequently, regularization, bar normalization, and leaky error activation function were used to prevent the model from overfitting. And in the last step, the sigmoid activation function was implemented. So in our research, we propose 3 different modifications of the generator architecture. These are the first model, in which the phenomenon of increasing resolution and decreasing dimensionality occurs, and the second model, in which the phenomenon of first downsampling and then upsampling occurs, and the third model, in which the phenomenon of increasing resolution and dimensionality occurs. Yes, and the next part will be told by my sister, Agnieszka. So the first type of generator mainly consists of the convolutional layers to increase the resolution of the generated photo. So when increasing the resolution, the dimensionality of the created photo are gradually reduced. Additionally, as in the discriminator, we use normalization and regularization techniques like batch normalization, dropout, and also leaky error activation function. And in the last step, we use hyperbolic tangent activation function to normalize pixel values to the range from -1 to 1. And the training process took us long 15 minutes for 20 epochs and 10,000 images. The second type of the generator uses convolutional and the convolutional layers. So first, convolutional layers were used to reduce photo resolution, and subsequently the convolutional layers were used to increase it. And this architecture resembles UNet network without the use of skip connections. And the training process took us long 52 minutes for 20 epochs and 10,000 images. And the last type of the generator uses only the convolutional layers. Of these 3 configurations, this model had the longest training process, and this training process took us long 99 minutes for 20 epochs and 10,000 images. So results for these three generators are very similar, and each of them produced faces very close to real faces, but the faces produced by the second generator are clear and sharp and have the most details. For the first group, the faces are a little blurred and mixed with the background a little. And the last group, the faces are the most blurred and strongly noticeable is the smooth arrival between the face and the background. So a lack of sharpness here. And additionally, for these three generators, the networks were not overfitted, so each generator produced unique images that were not in the training dataset. So in order to check which generator can encode and produce faces with certain characteristics from the training dataset, we propose our technique that will show us more precisely ability to encode these informations. So we conducted two tests, this time for a set of photos that involve only one type of image. So first dataset contained only duplicated images of a woman, and a second dataset contains only duplicated images of a man with glasses. So the results for the test for the first case were in the set were only pictures of the same woman. So the training process was the best for the first and second model because the features are the fastest encoded and detected from the training dataset. And for the third model, the images are a little blurred and not very colorful and a little blurred, and this effect was already visible in the previous section results. And the results for the test for the second case were in the set were only pictures of the man with glasses, and the results very similar to the previous. So all three proposed generator architectures are capable of generating images well, but the two first architectures proved to be more effective. So the two best generator architectures are generator using the mechanism of increasing resolution and reducing dimensions, and generator resembling the unit network without the use of skip connections. Additionally, both of these DC GAN structures train the fastest. And this is the end. Thank you for your attention.
One would like to ask a question, please. No, thank you once again for your presentation. I think you will take the Tomasz Borytut. So, we certificated, please. Free. Okay. Thank you very much. I don't know if we have a full presentation. No. So the session is closed. Thank you very much for your attention.
So I would like to say thank you for our chair of this section, Professor Zbigniew Muszalek. So
thank you very much.
Thank you very much. And this is small gift from our university.
Thank you.
Thank you. Sorry, so we found our last lost presenter. He was lost somewhere in space. But
so, okay.
Now we will have.
So we open the session once again.
Yeah, we will. But yeah, but this.
Good morning. I don't hear him. morning.
Can I show my screen?
Yes, please. Yes, give a presentation.
Thank you very much. So you show my screen?
Yes, we see your screen.
I have short presentation with results our investigation. I present investigation result modeling the intellectual behavior of team of robots based on the multi-agent simulation model. Model is show and consists of central control model, control system, road matrix, external environment, database, and robots, and count robots. Multi-agent simulation model is the ways for a system for modeling growth behavior of a team of robots and present before slide. This slide is task for robots. The following task relevant for interaction of a team of robots in conditions of incomplete information about the external environment, modeling the rational behavior of individual robots, making a decision for a robot based on the collective task, evolution by the robot, the result of a task. The study the growth behavior of a team of robots with the framework of a multi-agent simulation model, the follow scenario probed X number of combination of research robots placed on a site controlled by main robot. Research robots acts acts in the interactive of the main robot, which needs to get its route through the certain territory. The land area is set on the map in the from a rectangle or square. The algorithm for construction roads based on information from the model of external environment distributes the research robots into areas of responsibility and set trajectories for them to study the territory. We have two cases. Experimental data. In the first case, the number of robots fixed, and we select the position of the robots on the territory randomly and look at the combinations that suit us its term on the time criteria it takes to complete the group task. In the second case, we fix the time as a constant and try to fit into this time, continuously increasing the number of robots without the changing the initial location. Results results of experiments is present on graphics. For first case, the quality functional of performing the group task depends on the time t spent on achieving the goal. As a result of experimental studies, X number of simulation situations randomly set in which array of local targets, roads, and the number of robots are determined. The placement of robots on the ground and the assigned local roads them are random. A study of the group behavior of a team of robots is carried out on the base on an estimate of the delivery time of the load to a destination. Bisection on the group for points with minimum values along the y-axis, we can find combination that's corresponding to optimum in the given constraints time variant of arrangement of group robots and assigned target road to them. In the second case, the quality functional of performance the group task depends on Q, the minimum quantity of robots that is necessary for achieve the group goal for given time interval t equal const. Bisection on the graph for points with minimum values along the y-axis, we can determine the minimum requirements quality of robots with which it is possible to optimally complete the group task for fixed interval time. According to the result of experiments, it was found that an increase in the number of control points and the number of iterations to find the optimal route on the simulation field positively affect for optimization results. Thank you for attention. I have bad level English. If I not understand your question, we can send me to email on slide.
If anyone would like to ask a question. No, yes, please. A moment.
So thank you for presentation, and I was curious, what about the intercommunication between those drones, those robots during the teamwork, how they interact with each other on the mission, or how they share information with each other to increase results, better results. Okay, thank you.
If I try understand question, I see two variant for information between robots. It's central control or decentral control. With central control, it is maybe main PC for all robots, and it is all database for all robots. And for decentral variant, it is robots change information between units.
Answer? Is any more questions? No, thank you very much.
Thank you very much. Your question, you say email.
Again, the session is closed.
Goodbye.
Thank you very much for your attention.
Thank you.
So the session is closed. Thank you for chair. Now we'll have coffee break, and then we'll have special session on cybersecurity. Okay, dear colleagues, so let's continue our conference. And now we'll have a special session on cybersecurity, chaired by Professor Šarūnas Grigaliūnas.
Is will be presented by me myself, and all team is here. So yeah, if you will have a question, please ask us, and probably we will answer to this question. So first topic of this session is Fintech security challenges in control of the digital trustly against the money laundering. And me myself, Šarūnas Grigaliūnas, Professor Algimantas Venčikauskas, Rasa Bruzgienė, Angie Romanovs, and Ernestas Serkov. So all participants are here. And yeah, as you understand from the topic, our main focus is Fintech. So and we made a investigation and try to get some domains and get these points together from the Fintech and money laundering point of view. The key things what we will take away, or we will take from our investigation, is technologies. Which exactly technologies should be should fit to the fintechs. Second thing, we will as well take a look at the blockchain as a possibility for the cryptocurrency. Later on, you will understand why we will look at this domain or this technology. Third thing, what we take a look on the cybersecurity point of view and the privacy issue, which we get and extract from these domains, and the possibility for the money laundering schemas, which probably, as you will know, the mixer is one of these. Regarding our topic, we raise 4 main questions for ourselves. So basically, this question will be answered in our research. And this question is, the solution, the cybersecurity solution, anti-money laundering approaches, the blockchain system itself, or the control of that digital trustly, and operational, technical and operational control leaks. So as you understand from now, we little bit split these two topics in the technical and operational. Okay, so regarding the blockchain technology, we just take a couple takeaways. So what is potential probably threats or why the blockchain technology was used, because of the different layers on the blockchain. When we're talking about the layers, what we mean by talking the layers, we're meaning the cryptocurrency, and by doing the transaction on different layers can be used with the mixer schemas. So it could be hidden the evidences or the possibility, you know, to track this transaction. So that's what we look into the blockchain. The risks which we identified, it's very easy, you know, to do this anti-money laundering things by using different type of mixers, and it could be increased up to 97%, you know, to be untrackable if you use these different layers. So we identified that it is possible, you know, to lose the digital identity. So when you lose the digital identity, so it means that you lose the footprint or the evidence, you know, to track. I can give you a very simple example. For example, you have a one wallet, so the wallet will be filled out with the currency, and never ever, you know, get the transaction to another wallet, and the client will be, you know, founded from the different wallets. So we are losing the identity between these two wallets. So there are no possibility, you know, to track. Of course, there are a lot of different techniques, but it will be another article from our research team. So yeah. So what the trustworthy digital trustworthy in the blockchain? So we try to identify a couple of them. This decentralizing general things or the natural things, and probably we think or we identified another possibility, you know, to do the stronger identified. By saying strongly identified, probably those who already have a digital wallet, you know, this KYC, so it is know your customer identification things, and they become stronger and stronger. So they ask you for the biometrical identification, your ID, your face, your geolocation, and so on and so on. So yeah, so that's how it could be increased. Yeah, I a little bit touched this digital identity. So it could be the not only attributes-based things, but as well it could be the individual control. Probably you already know this ATMs, so the machines who gives you a digital currency for getting back your biometrical data. They are talking that it will be, you know, something good in the future. For example, you will be digital. You will have a digital ID based on blockchain. But yeah, it is only a few projects right now. Why we think the anti-money laundering topic it is very sensitive today. As I provided to you example of, you know, possibility, you know, to lose the tracking thing, lose the footprints. So there are a lot of technologies where you cannot control. So by saying cannot control, it means that we need to somehow identify these gaps. I mean the technical and organizational gaps, and probably these could help to track, or at least to build the later probably the methods, modules, or methodological things, or even regulation if you go with the government layer. A nice picture generated by Midjourney, as you understand. So yeah, and what we get. So this is the things when where we came to the main our research domain or research results. So we, as you see, we identified a lot of different domains and tried to get them together by dividing in 3 main areas. So we pay attention on digital identity, the transactions, and the money laundering, because that things we are thinking very sensitive when you try to track the possibility, the spammers or cheaters or whatever it will be, or any kind of possibility, to hide the transaction. For one of probably the mostly useful example, it is money from the casino, which can be go through these mixers. So yeah, so basically we identified a couple of mechanisms. So we are thinking about the zero trust proofs, the compliance things, and the what we get. We just try to draw this areas how it can be covered with the digital trustly controls. So as you may see, probably we would like this spider style graphic. So as you see, the dividing between, for example, privacy and cryptography, or digital identity, or the decentralization. Yeah, so basically the areas mostly covered or not. Second thing, we talked about the technical controls. So we identified a couple of them, and you will see this spider presentation with the next slide. But the smart contracts, multi-signature, and cryptography, these controls are more specified. And yeah, and we try to draw and present the technical controls for the fintechs, or in the fintechs security. So basically what controls are mostly trackable or backwards untrackable. So you see, for example, decentralization. It could be the thing which is mostly untrackable. I know if you're familiar with the Monero, so it's one of the coin which is mostly decentralized and probably hard to trackable. But the hardest thing is when the startups building the new coins on the layers, and they just get this testnet things, but this testnet is linked to the real world. What does it mean? It means that, for example, you put there some. You first of all you exchange your bitcoins into the shitty coins, whatever it call it. Put on this testnet. After some time, you do the transaction to another real network, For example, you exchange again to the Monero, then you exchange to the Ethereum. And when the startup destroys this testnet, there is no possibility now to track it. So what you get, I mean, from the forensic or from the, for the government point of view, or for the money, for the risk officer point of view, you get that money from the wallet, where was the Bitcoins, was sent to the testnet, which never exists at the moment, is just generally destroyed, and you didn't know the next step. And the next step, it is white money, I mean white crypto money. So that's things what we identified, and definitely it is issue now to make it stronger and stronger. Another area where we look at, so we are looking at OPSEC control. Definitely we identified the modules which is mostly came from the regulator. It is the EU bank, for example. Locally we have a Lithuanian bank, and they are translating the information security measures and requirements from the EU bank to the fintechs. So yes, they are strongly regulated. Definitely, you know that upcoming this DORA regulation or MiCA, I don't know if you're familiar or not, but they are more strongly regulated fintechs. No matter what, the fintech still have a possibility, to do these transactions, or they call it they call it the getting money for the coins or the currents. So they are looking for investors generally, but the thing is that investors putting the money, I mean the real money, once with the possibility 1 to 100, for example, and they give the startups give them like a 100 coins, whatever it call it, and later on when they do the exchange back, so they have if someone put on the network the real money, they can extract for this virtual money real money. So it is very, very good schema, to get the real money back from the network, even it is regulated by the governments. So it is, I could say it is legal, because the investors do nothing illegal. They are putting money, they are expecting some outcome. They're expecting the money for the investment. And yeah, network is grow. Someone from the, I do not want to say, but someone the country which is related to the war put the money on the network, and it is possible this drawback without any illegal issues. So the operational controls should be here as well. So we identified a couple of them, and as I said previously, the regulation should be the mostly focused, and one more, which is the access control. So what we identified by access control, there is one big issue, because there is only virtual profile, and without what I mentioned previously, biometrical identification, you cannot know what exactly is behind this profile. So still there are a lot of startups which is doing the pre-sale without the KYC, without the know your clients. What does it mean? It means that someone who wants to put the black money on the network and get later on white money from this layer 2 or 3, or when the testnet will be destroyed, is under control or without control, depends on which side you are. So we identified that access control should be one of these areas, or most focused areas. Yeah, so getting close to our conclusions. So we identified areas where could be the stronger, I mean the technical security and ops security part. So there are some unmanageable risks, and there are some issues with the user controls. And the last thing, it is the biometrical, or the possibility to track the money sender and getter. Probably the most important part is getter, because if the transaction in between will be untrackable, so it means that but the risk officer cannot confirm that transaction is real instead of money laundering. Yeah, and go to the conclusion things. I spoke about the controls, what was identified, but probably it is not enough, to increase the controls, because this is the more high level view on the anti-money laundering compliant things. There are still a lot of areas, to develop the controls, mechanism, models, and one of these we are working right now. For example, to identify time window between the money goes out and goes in, and probably it will be the two different wallets. But by tracking this times, we can be very close of this transaction who was made by one, who was collected by one pool to make this transaction, and put it out and get it from the different wallets. So it will be another pool. So time window will be the next our research focus. So that's what I would like to share for today with you, and please ask us whatever you think it will be useful. Or you could, if you want, you can share your experience by tracking the transaction. Did you heard from your neighbors that they lose the money and there is no possibility to track back? Because we have a lot of these cases that someone the first step what was happening, someone put the money on your wallet, and they ask you, can you send it back?
Yeah. That's called recycling.
Yeah, and basically this is the trap. This is the trap, because if you are very polite man or woman, you will definitely you do not need someone money, and you will give this money back, and definitely you will lose all your wallet.
Usually it's part of some sort of scam.
Yeah, scam. Yeah, definitely.
Roman scammers use that plot many times, and they send you money also to establish trust. And they ask you, please, can you send it to this? And it's with a lot of different excuses. And you, from victim, you become a criminal because you are basically acting like a mule and you are recycling money.
Yeah, and you are part of the,
you're part of the network. And
yeah.
You can be liable for that.
And no one knows that you just ask politely, to do things.
You can tell the judge later on, but you're going to be in trouble because technically it is recycling.
Yeah, and it came from your wallet. That's
exactly.
That's the fact what was be identified by the police.
But may I ask just after that? I'm very curious about what you mentioned about that black hole in regulation, that you can have a startup in pre-sales and you can put real money and then you don't need KYC at that point. Yes. And then you can...
Because it is testnet. Testnet is not required for the identifying.
That's a freaking huge hole in regulation.
Because I'm developer, I'm just supporting you.
Yeah, but with real money. It's crazy. There is all this regulation we were talking before, hyper regulation, and you can put real money in.
Yes. Yeah, because
that's a huge hole.
Yeah, so that's what we identified and said. Look, please, at that small thing, which is it's not the black hole. It is it is testnet. There are some testnet which is just generated for the simulation transaction, but there are a lot of testnet which is linked with the real world and can be used as a mixer, if I could say like this.
That's a huge forgetfulness by the regulators.
Yeah, gap in the regulation.
More questions?
All right, probably that's it from the first talk, and how I can invite. Thank you. Yeah, that's what we expect. I know how to.
It means that.
Yeah.
I should give you a certificate.
For me. Okay.
Yeah.
Thank you. And I should as well give this certification to the team what is participating as well, yeah? So, guys, if you don't mind, I will give you after all session. All right? Thank you. Okay, so how I can invite now this second presenter? Okay. Okay, so the next topic will be the comparison and assembled learning and deep neural network for the malware detection. Comprehensive. Where is our guys? Okay. And yeah, we get you. Could you please share your slides?
Okay.
So definitely we'll talk about the malware.
Yeah. Hello everyone, I hope you are all doing well. I'm so proud to present our article in comparing ensemble learning and deep neural network for malware detection and the third international conference on information and software technologies. My name is Hajar Uzza. I'm a PhD student at National School of Applied Sciences, Ibn Tufal University, Al Qunaitira, Morocco. This work has been supervised by Professor Fdoua Khennou from Université de Moncton, Canada, and Professor Abdelawi Abdurrahim from my institution. In this presentation, we will begin by an introduction to the importance of machine learning in malware detection field. Next, I will provide a literature review covering analysis approach, malware analysis approach. Next, I will explain materials and method used including dataset models and evaluation metrics. In results and discuss section, I will compare the performance of ensemble learning model and the deep neural network model. Finally, I will conclude with a summary key finding. Recently, machine learning approaches has proposed as a solution for the shortcomings of signatures-based detection because of their ability to predict labels for new inputs. Machine learning models, including decision trees, SVMs, and random forest neural networks, are used in malware classification, detection, and analysis approach. For malware analysis approach, we have four types: static analysis, dynamic, hybrid, and memory analysis. Static analysis is a technique to examine the file without executing. Focus on analyzing the structure, the file structure, code, strings, and metadata. It doesn't require running the malware and running the malware. It's which make it faster and safer. However, it's less effective against new and encrypted malwares. For dynamic analysis, requires running the binary in a live environment. This environment is usually a secure sandbox or a test environment, such as Cuckoo sandbox. Dynamic analysis also network traffic and communication are captured and analyzed. However, advanced and obfuscated malwares are often designed to detect virtual environment and hide or change their behavior. A hybrid analysis combines the advantage and limits of both dynamic and static analysis. A recent technique, memory analysis, involves extracting features for memory dumps using tools like volume laser and volatility. Benefits of this methods that is effective against obfuscated malware and zero-days attack. The objective of our proposed detection model, firstly, evaluate the effectiveness of ensemble learning method versus a deep neural network for malware detection. Second, enhance model efficiency, promote strategic feature selection to improve training speed and detection accuracy. And finally, assess both binary and multi-class classification scenario uses SysMalMIM 2022 dataset and various performance metrics to determine the best detection approach. For the dataset, we choose SysMalMIM 2022 because it provides a comprehensive set of real-world memory dump samples, and its structures supports advanced methods. For SysMalMIM 2022 dataset, generated by the Canadian Institute for Cybersecurity, published at 2022 International Conference on Information Systems and Security and Privacy. It contains 59 features and 59,526 memory dump entities collected from both infected and uninfected systems. It has a balanced composition of 50% benign and 50% malware samples. focus on three types of malware: Trojan horses, spyware, and ransomware. And we move to the most important step in machine learning process as data pre-processing. We start by loading a dataset and convert it into data frame using pandas library to simplify data manipulation and analysis. We process the data by removing duplicated value, and we use a label encoder to return the categorical labels to the numerical value. For binary classification, assigning 0 to benign, 1 to malware, and for multi-class classification, 0 for benign, 1 for ransomware, 2 for spyware, and 3 for Trojan. Then we applied feature selection methods such as filter method, wrapper method, and embedded method. The objective of the applying feature selection method is reducing non-informative variable and choosing only the most relevant features from the dataset for improving the model performance and reducing overfitting. Feature selection models categorized into supervised methods assess relevance without target variable, and the supervised method which we applied in this study. Supervised methods require a target variable to identify the important feature for the model. Supervised methods include three types of methods. Filter method uses correlation static score to evaluate the features, and wrapper method iteratively select optimal feature subsets throughout model training, and the embedded method combines filter and embedded and wrapper method using algorithms like lasso, ridge, and random forest. We applied all three methods to identify the 20 features based on their frequent occurrence across various methods. Those graphs shows the top 15 features selected by each method. The filter method consistently identify feature in both binary and multi-class classification, whereas the wrapper and the embedded method selects different features for each case. Wrapper method selects the optimal subset for binary classification and another optimal subset for multi-class classification. For the embedded method, we used ridge regression and random forest. After the selection of the 20 relevant feature, the ensemble learning and the DNN models for SysMal MIME dataset 2022 dataset involve similar preprocessing data splitting with 90% training and 20% test, and evaluation metrics and 5-fold cross validation. The main difference is that our ensemble learning model combine combine the prediction of three models: random forest, SVMs, and decision tree, using soft voting technique to improve the decision accuracy. The NN model applied a deep neural network with two hidden layers, ReLU activation and a drop for regularization. Those tables compare ensemble learning model and DNN model for binary and multi-class classification. Ensemble learning outperforms DNN in accuracy, precision, recall, and F1 score. In multi-class classification, ensemble learning also shows a better precision and recall. However, the NN has much faster training time. The provided confusion metrics further highlight the ensemble classifier superior performance. It made only a singular misclassification, whereas the DNN error to categorize 96 instances, 61 benign as a malware, and 35 malware as a benign. We had employed a cross validation to evaluate the stability of this model. The method shows that the ensemble learning remains constant across different data splitting, offering further confidence in its performance. For multi-class classification, ensemble learning achieved a robust record score of 96, demonstrating its strong capabilities to distinguish between malware categories. And while our DNN model performed lower than ensemble learning model, it still outperformed other studies. In this table, provide a scientific comparison of DNN models for malware detection, evaluating aspects such as number of layers, learning technique, drop rate, activation function, batch size, and accuracy. To conclude, this study compares a malware detection systems using l'ensemble learning combined decision tree, SVMs, and random forest, while with a deep neural network evaluating its performance, the performance on SysMal MEM 2022 dataset, applied both binary and multi-class classification. The results show that the ensemble learning outperforms the NN offer better performance. Thank you for your attention.
Thank you. Do we have any questions? Please.
Thanks for the presentation. The accuracy of an ensemble learner depends on the individual learners and especially on the heterogeneity of the individual learners. Did you also test some other individual learners other than support vector machine, decision tree, and random forest to just get a better picture of what individual learners might outperform the neural network and which combinations do not? Thanks.
I didn't understand the question.
Could you repeat that again? Probably, you know.
Yeah, I'll try it again.
Yeah.
You just used 3 individual learners, right? Support vector machines, decision trees, and random forest. Did you also try some other learners other than these 3 to compare them against the neural networks?
I tried to make another ensemble learning with the other algorithms.
Yes.
That's no. Especially I Actually, I trained the data set with algorithms, a single algorithms, decision tree, a random forest, and others machine learning algorithms. After that, I tested the performance and based on the accuracy of each of those algorithms, I decided to combine the three top the three top accuracy. The three top algorithms that give better accuracy.
Okay, yeah, and if they are the top three, maybe it could be also a good idea to not select the top three, but those having quite different correct predictions. So if one of the algorithms predicts better in one area than another algorithm, these two might be a good combination for an ensemble learner.
Yes.
Okay, yeah, thanks.
Merci. Thank you.
More questions?
We didn't have questions, so thank you again.
Thank you so much.
Okay, and seems like with the next presentation we will have a hacker. Because the topic is radio hacking and it is impact on the navigation system. So, on the navigation system. Okay, do we have the topic is very related also to different jamming system. Okay, welcome on board.
Hello, hello.
Yeah, please start with your presentation, and floor is yours.
Can you see my screen?
Please only please do the full screen mode. Yeah, now it's perfect.
Okay. Hello everyone, I'm Georgi Tomadze, student of Tbilisi State University and member of Scientific Cybersecurity Association. Thank you for this opportunity to present this work. Our today's report is about radio hacking related problems and methods to solve it. It's a common idea that in the 21st century, any person has daily contact with technologies that work on radio waves. The radio wave itself is electromagnetic radiation, the wavelength of which is longer than infrared radiation in the electromagnetic spectrum. As technology relies heavily on radio waves, cyber attacks have increased. Today, we will discuss their dangers, share knowledge based on practical trials, and show you a demonstration. The history of radio waves begins at the end of the 19th century, when Heinrich Hertz first demonstrated the existence of electromagnetic waves. Radio hacking usually involves the unauthorized manipulation and interference of radio signals. It includes the exploitation of vulnerabilities in radio systems. Our report today is about cybersecurity in aviation. The modern aviation system relies heavily on radio technologies, which are essential for the efficient operation of this complex system. Most of the system uses the VHF, very high frequency range of radio frequencies. This system includes the following. First, voice and written communication between the air traffic controller and the pilots, and second, use of ADSB and its integral part, GNSS. Using them, it becomes possible for the aircraft to broadcast its position, altitude, and other important data. This information is critical for the air traffic controllers, as the above has serious vulnerabilities that could lead to dire consequences for an attacker. An attacker can impersonate the signals transmitted by the aircraft and pretend to be a flying object or change the data transmitted by the authentic aircraft. This action could cause critical damage to aviation infrastructure and airflow. In addition, other radio technologies are used in the aviation field, although they are outside the scope of our presentation. This photo based on an ADSB source shows an aircraft that was actually destroyed by bombing on February 27, 2022, during the Russia-Ukrainian war. The photo was taken a few days later. It was an ideological cyber attack. For the demonstration, we will use the device HackerF. HackerF is a versatile software-defined radio platform known for its flexibility and open source design. It allows users to explore and experiment with different radio frequencies and provides reception and transmission over a wide range of radio signals, from 1 MHz to 6 GHz. The demonstration is held in a controlled environment. In this video, the transmitting device and antenna are marked with grid frames, and the receiving device and antenna are marked with red ones. At the push of a button, an attacker would launch a kind of a ADSB attack, sending a digitally encoded signal containing data from a non-existent aircraft. Then the receiving device momentarily decodes the signal and displays the non-existent aircraft data on the screen. You will agree that today we rarely find such a person who doesn't have contact with GPS. GPS is an American satellite system that belongs to GNSS. In fact, we also use its other systems such as Galileo, GLONASS, Beidou, etc. We use this means of navigation in our daily life, but we might be surprised how dangerous a cyber attack on it can be. The principle of its operation at first glance is quite simple. It works by using a network of satellites orbiting the Earth to accurately determine a position on the surface of the planet by calculating the distance between the receiver and multiple satellites to define a specific location in three-dimensional space based on the time of the signal and the known positions of those satellites. Today, a GNSS receiver is available to everyone. All the types of GNSS satellites broadcast on different channels, namely L1, L2, L3, L4, and L5. Information is broadcasted from GNSS satellites at a speed of 50 bits per second. It transmits satellite orbit data and satellite time, which is indispensable in the case of civil aviation. GNSS vulnerabilities combined with the radio frequency interference are causing concern in the aviation field. The disappearance of the GPS signal is becoming increasingly common in civil aviation, especially in politically tense areas. There can be many reasons for this, but it's likely that they are provoked, or since signal suppression is no longer a difficulty today. Although jamming is very dangerous and may happen occasionally, spoofing attack is even more dangerous and predictable. GNSS spoofing is a technique in which false signals are transmitted to the receiver, causing it to calculate an incorrect location. It can be falsified by generating radio waves that mimic authentic GNSS signals, which sends false information to the receiver. GNSS spoofing increases threat risks because of its use. It can be used to fool navigation systems, disrupt critical infrastructure, or interference the path of autonomous vehicles and aircraft. In 2010, a similar attack was carried out at the Hanover airport. Although this all by accident. This sounds incredible, of course, but this case has already been investigated, and it has been determined that the source of the false signal was the ongoing testing by nearby hangar. This one shows again how easy it can be to spoof signals like this. Since the aircraft positioning system was fooled, the ADSB data was automatically changed accordingly. Also, in 2018, Russia accused the US of falsifying the authenticity of the drone and using it to attack a Russian airbase in Syria. Also, in the past few years, there have been many location spoofing incidents near the Russian border, and drones are believed to have been placed at nearby airports. Simple and relatively complex attacks can be carried out on GNSS. In a simple attack, the attacker suppresses the authentic signal and broadcasts his own fake signal, causing the receiving device to tune into his signal. Detecting and avoiding such a simple attack is not very difficult, since the fake and real signals will not be synchronized, and these can be easily detected by software. In the case of more complex attacks, the attacker tries to covertly convert the receiver from an authentic signal to a fake one. For this, he must first mask the authentic signal with the fake signal so that all indicators are initially similar to the authentic one, and then change it in his favor. Greater the involvement of technology in modern life, the greater the likelihood of insecurities increases. Naturally, technological regression can't help us in this, although there must be certain aspects that must be strictly protected. We have already explained the dangers of those attacks, and now we can talk about the methods of solving them. First, to prevent GNSS spoofing, we all think of encrypted data exchange. But with today's technology, that's practically impossible because of the distance they have to broadcast the low frequency, which doesn't allow the implementation of mass encryption. Unlike the military unit, the military sector is capable of encrypted communication only because they use the same encryption key, the English encryption algorithm, sorry, that the receiver uses to decode the signal. All receivers use the same key. Current GNSS systems only allow communication to be encrypted with the symmetric algorithm. This is unsuitable for civilian use as storage, distribution, and management of different encryption keys is practically impossible. In fact, one of the appropriate ways of protecting may be a verification mechanism. The use of additional sensors, such as inertial navigation system or alternative positioning technologies, plays a crucial role in the protection of navigation systems. By combining data from multiple sensors, including GPS, these systems can maintain accurate positioning information even if in difficult environments, or when the GPS signal is interrupted. Additional sensors provide a backup mechanism that is responsible for the continuity of navigation and protects against potential threats such as GPS spoofing or blocking. We can consider multi-frequency receivers as another protection mechanism. Multi-frequency authentication in GNSS allows us to use different frequency signals such as L1, L2, and L5. This approach enhances accuracy by reducing the effects of environmental factors such as the ionosphere blurring the signal and resisting interference and spoofing attempts. Multi-frequency authentication contributes to the reliability and security of GNSS, making it valuable for applications that require accurate and reliable positioning information. We may also have active monitoring of the signal quality as a version, which ensures detection of changes in signal, anomalies, and unauthorized interference. Okay, we can talk about the ADSB spoofing solution methods. By using message authentication, we can make sure that the data is not forged. Authentication of the message can mean an electronic, so cryptographic signature, with which the recipient will confirm the integrity of the message. Or the easiest way, let's go back to the compass method. In this presentation, we explore the dark side of radio technology, delving into the dangers of GNSS and ADSB spoofings. However, by taking the necessary actions and promoting cooperation, we can strengthen the security and reliability of these important systems. Thank you for your attention. I'm ready to answer your questions.
Do we have a question from the audience? All right, so I have one question. By the way, nice stickers on your laptop.
Sorry?
Nice stickers on your laptop.
Where can you see my stickers?
Security breach.
Yeah. All right. So it was a nice trick. Do you because you did some measures for spoofing, as I understand. Did you measure how many watts do you need to know for spoof? And measure the distance how it works, or even maybe you create your own direct antenna for this test. Did you try something?
No, I haven't tried yet, but we'll continue our research and we'll be able to answer this in the future. Sorry.
I'm just curious. All right, so thanks again.
Thank you. Thank you.
All right, and the next topic is neural network approach to check cheats detection. Let's play the chess. Do we have do the more hacking things and come back and share your results. We definitely want to do this session bigger, especially from this hacking point of view, because everyone is curious. What is the gaps? What is the things? Yeah. So it is. Do we have any issue with the speaker? All right. We see you. Hi again. Please share your screen. Yeah, share your slides.
I guess I shall start now.
Yeah. Now we see it. Floor is yours. Please.
Okay. So, hello, my name is Zura. Today I'll be presenting to you a neural network approach to chess cheater detection. Before I go on to explaining the project itself, I'd like to talk about and give some context that is needed for this work. First of all, let's analyze the statistics. During 2020 pandemic, online chess saw a massive 500% increase in popularity due to COVID lockdown. This obviously brought a huge influx of new players to the platform, which is good for the sport. However, this also brought in a huge wave of people who use engines or computers to obtain unfair advantages during their games, so-called cheaters or centaurs. And what this pandemic and what their sudden increase in numbers has revealed is actually that the current existing anti-cheat systems that are used to filter out these players are not effective at all. A lot of the top players, most notably Magnus Carlsen, have shown their distrust towards these systems, claiming that they are incapable of capturing well-disguised centaurs or even intermediately disguised centaurs. Obviously this sort of attitude, especially in the top levels of chess, is very unhealthy. It's settling a lot of conspiracies. It's sparking a lot of dramas, a lot of accusations, false positives. So there's a lot of chaos in that regards. Now, let's look at how the main parameters sort of what the modern and most cutting edge anti-cheat systems are using, which is Centi-Pon laws. This is sort of the monolith, the central stone upon which everything else is built around. So what is this parameter? Chess engines or chess computers have built-in analysis functions that are able to calculate and evaluate position with a number. So if the number is positive, the advantage goes to the white pieces. If the number is negative, the advantage goes to the black pieces. And the way that computer engines work, computers have surpassed humans long ago in terms of chess. Humans are incapable of playing as perfectly as the computers are, which results in us making the assumption that computers' evaluation of any position is the absolute truth. So since the computers are superior mentors and their evaluation is the absolute truth, we as imperfect beings are incapable of making the exact moves they want. So when we make a move, we're going to make an inaccuracy. We're going to play a suboptimal move that is going to cause a fluctuation in the evaluation. If the objective evaluation of a position was 0.7, we're going to make an imperfect move that's going to cause us to, let's say, lose advantage to white and drop the evaluation down to -1. This changes in fluctuation is what is recorded and regarded as Centi-Pon loss. And the way that the anti-cheats work is that they look at Centi-Pon loss, and it's mathematic derivatives and other forms of transmutations. And they see, okay, if the Centi-Pon loss is too low, that means that the correlation with computer style of play is too high to be naturally be played by a human, which is then automatically assumed that this game was played using a computer. The main issue with that is that Centipon loss has also a 99% correlation with a player's strength and rating. So the stronger a player is, the lower his Centipon loss is going to be naturally. And when we're entering the sort of grandmaster territory where everybody is incredibly good, the Centipon loss parameter becomes insufficient at distinguishing them, because the margin of error is so small already that it's very easy for a grandmaster to have a lucky game and accidentally exceed the threshold that would give out a false positive, or vice versa for a player to use an engine and exceed this threshold by just a bit. So Centipon loss in its essence is inefficient, and it's being compensated by other forms of methods like monitoring time and other things. But for now, we're gonna focus again on Centipon loss and trying to enrich this core parameter. So let's move on to the proposed model. The proposed model utilizes Maya individual neural network to calculate Centipon loss in a very unique way. So there is a suspect, and we take the suspect's individual data, which is his history of chess games, and we're going to train Maya individual neural network based on those games. Maya individual aims to study from the games of the given individual and then emulate his entire personality when it comes to chess, and play the moves that are not objectively the best or objectively the true, like other engines try, but rather it tries to play the move that the given individual would play. It tries to predict what the player wants to play. So then this sort of brains that are trained by my individual are passed on to another neural network, which is Lila Chess 0. This is simply to give Maya some limbs to work around with, to have the power to evaluate positions and give us its metrics. And then the individual data and the cheater data will be passed on to the Centipon loss extractor script. So both Maya will be analyzing both the individual data and the cheater data and giving us the Centipon loss based from its own perspective. This will then be passed on to sequential model as well as the regular Centipon loss data, which is usually calculated by traditional neural networks like Stockfish. And that as well will be passed on to the sequential model. The control model for a comparison to show the difference of improvement, there will be no use of Maya individual. So instead, Stockfish will directly be loaded into the Centipon loss extractor and will analyze both the cheater and the individual data, and only those parameters will be sent over to the CNN. So let's discuss the Maya, what was used. It's an open source project available on Linux. It has its own ways of setting up, and Lila Chess 0 was used because the creators of Maya themselves give recommendation to using Lila. It has been tested on that and has been proven to work. So the same sort of scenario was replicated in this case. The final config was generated, and then it was passed on to Lila Chess 0. After that, this is the Centipon loss calculator script, where all of the Centipon loss data is extracted both by Stockfish and by Maya. It depends on what engine we choose to load there. And then all of these parameters are passed on to the sequential. We go through the standard procedure of training a neural network by, like, we normalize the parameters, the string parameters, the integer parameters, then we train the model, and finally we arrive at the results. So without the Maya, we achieved an accuracy of roughly 78%, and with use of Maya, the recorded accuracy was 94%. So there is roughly a 16% increase in accuracy based off of these parameters alone. And to better visualize on what this Maya extracted Centipon loss parameter does, is it takes the one-dimensional graph that is done by Centipon loss, which obviously, in other words, measures a player's correlation with computer, and it actually turns it into a two-dimensional graph. So we have correlation with computer and we have correlation with individual style. And this allows us to filter out a lot of the false positives that were previously present with using simply or only Centipon loss. Because now when we're talking about the top level, we have obviously, it's obvious that there will be high correlation with computer because all strong players already have low Centipon loss. So now we're going to be directing our attention towards how much different are they playing from their usual self. If the recorded accuracy is suspiciously high, and in addition, the suspected player is deviating from his own usual style, it is much more likely that he is receiving some sort of computer assistance. Meanwhile, if the player is playing in his own style and also has a high accuracy, that just means that that's a very good player that perhaps got very lucky in his game. He played really well. He was sort of in his comfort zone and was finding moves that are easy for him to find, which is backed up by the Maya neural network. So this is it for the presentation. Thank you for your attention, and I will gladly answer any questions that you guys might have.
All right, so yeah, we have a question.
Very interesting talk. I have a question. Isn't this true that really strong players can vary their style of playing and then it becomes difficult to detect it?
Part got cut off. I believe you mentioned that the strong players have various styles, and that's why it's difficult to be detected.
Yes.
Yes, that is true in terms of strong players need to be flexible. However, we're training the Maya neural network to sort of predict the moves they would play. And there are definitely nuances that even the strongest players play. There is usually a general rule of thumb when you're looking at top grandmasters that you could say are their signature moves. I'm not talking about like old classics like Bobby Fischer, but even when we talk about modern landscape, there are certainly these features that, well, as a result of this experiment, my individual is clearly capable of picking up on. But that is a good point, that training these models on stronger and stronger players becomes challenging in a way that it's more difficult to capture their exact style. However, it also becomes easier because we have much greater data sets to train it off of greater players. So people who are grandmasters have tens of thousands, if not hundreds of thousands of games that Maya could be trained off of. Meanwhile, if we're talking average chess player, the number could be very well between 10,000 or even lower. So there's this sort of a compensation for the vastness of the style.
I have one general question. What is your rank at chess.com or Lichess? Because you have very interesting findings.
So I mainly play on leeches.org, and my ratings sort of vary in terms of, or have recently started to vary across different time formats. Usually when I'm pretty stressed due to perhaps studying or research or other stuff, my rating gets greatly affected by it. But I usually hover around between 2000 to 2200 ELO across different time formats. So if we're talking bullet, 2200. If we're talking rapid, 2100. And if we're talking classical, I'm 2050, though I have been 2100 at one point.
Applause. Thank you, thank you, thank you all. And I think this was the last our topic for today. So, thank you for the participation. Hack and come back next year. And yeah.
Thank you very much, and thank you for our chair, Šarūnas.
Another one certification. Thank you.
So I can leave now, right?
Small gift.
Yeah, you
Small
can
gift.
leave because I have a present for me. Thank you, and yeah, guys, come back.
Yeah, so thank you very much, and this section was the final one today, so thank you very much for participation, and hope to see you tomorrow. The registration will begin on 9 a.m. and we'll have the keynote speech provided by Alessandro Corino. Yeah, so I hope to all of you to see tomorrow. Yeah, thank you very much. See you tomorrow. Bye.